What we do here is go back.
Ganesh, I am ready. Good morning, everyone. This is Dr. Manivannan, Dean from Dr.M.G.R. Educational and Research Institute, Chennai, Tamil Nadu. I wholeheartedly welcome you all for this one-day online FDP on challenges in research and innovation organized by Faculty of Humanities and Sciences in association with Abdul Kalam Research Center. Today we have eminent speakers. Before to that, we will have Tamil Thai Valthu. I request our administrator to play the Tamil Thai Valthu. Please, Mr. Ganesh.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you very much, Mr. Ganesh. I am happy to present my welcome address. Good morning, one and all. I am Dr. Manivannan. As I have introduced myself, I am welcoming you all for this one-day online faculty development program. First of all, I must thank my Honorable Chairman, Founder Chancellor of our University, Dr. A.C. Shanmugam, and Engineer A.C.S. Arun Kumar, President of our University, who have given the sufficient sanction for organizing this kind of innovative event for our event to the research scholars. And I welcome Dr. Geeta Lakshmi, Vice Chancellor, Dr. Gopalakrishnan, Provost, Dr. C.B. Palanivelu, Registrar, Dr. Malini Pandey, Joint Registrar, Humanities and Sciences, Dr. Ramlingam, Joint Registrar of Phase II Campus, and Deputy Dean Dr. Rajavarman of our Phase II Campus. We have 7 eminent speakers for today's FDP. There are 7 wonders, 7 colors in the rainbow. Like that, today we have 7 eminent speakers for our today FDP. Dr. S.P. Tyagarajan sir, well-renowned scientist, come academician, who served as Vice Chancellor for Madras University and presently working as Dean Research of Dr. Ramachandra University, will be sharing the first session with us. And right now he is readily available with us. And Dr. Shekhar Sheshagiri, joining from USA, and Dr. Ashok Rao, Associate Director, R&D, Research and Consultancy, joining from Manipal Institute of Technology, Dr. Shakti Pandi, Associate Director from Sedu Institute of Technology, Dr. Rama Vaidyanathan, Director R&D from our institute, and Dr. Venil, Advisor from Dr. APJ Abdul Kalam of our institute, and Dr. Manoj Kumar, Scientist from eFlipNet. This is our university photos. We started our institute in the year 1985 in the name of Tirumati Kannamal Educational Trust, and we started Thai Mugambi Polytechnic College. And in the year 1988, we started Dr.M.G.R. Engineering College. In 1991, Thai Mugambi Dental College. In 2003, we clubbed to both the institution and raised to the level of deemed university after obtaining the MHR DUC approvals. And here I am listing the various faculty available at our Dr. M.G.R. University, right from engineering and technology, medical sciences, dental sciences, pharmacy, nursing, physiotherapy, H&S, architecture, management, computer application, education, distance education, hotel management, faculty of law. We have everything. I used to tell few of my friends that except veterinary sciences, remaining all we have. That is our present strength. And of course, today we will be hosting Faculty of Humanities and Sciences in association with Dr. Abdul Kalam Center for Excellence. Here are the list of projects approved by the central government funding agencies. It's this Abdul Kalam Research Center is the Center for Excellence doing the projects connected with the biotechnology and specialization in terms of innovation and entrepreneurship. The funds are in the recent times we have obtained a 3 crore project and through which we will be funding 25 projects of our students, and already 3 are have got the entrepreneurship cell campus starter as campus starter. Our university is NAC accredited and few of our engineering departments are ABET accredited, and most of the engineering departments are and management science departments are ND accredited. Coming back to today's program, this COVID-19 has played a major role in today world. Of course, our education industry also has faced many problems. Due to lockdown, we are not able to come down, and of course, our scientists are working hard to find a solution for that. Meanwhile, the researchers are having a chance to listen to these kind of special sessions organized by our university during this lockdown period. This good research needs a lot of things in addition to the interest of the individual researcher. They are nothing but all the factors are being listed as special sessions, and we have identified the sufficient speakers for these topics: how to write the proposal, how to find a collaborator, how to submit and where to submit. All the factors we have identified, and we have identified the sufficient speakers also, and we will be having today program on research and innovation. This is the agenda. Of course, after this welcome address, Professor Tyagarajan sir is available here, and he will be presenting research and innovation ecosystem in Indian universities. Later, we'll be having a 10 minutes tea break, then followed by Dr. Shekhar Seshagiri, President MGR of India, as well as CEO ModMap Therapeutics USA. He will be joining after tea break. Then Dr. Shakti Pandi from Sedu Institute of Technology, giving idea about how to write the research proposals. Then Venil of our institute, Dr. Venil Madam of our institute will be giving how to do research and publish on a shoestring budget. Then followed by Dr. Rama Vaidyanathan, Director R&D of our institute, giving idea about collaboration is the key to good research. Then 50 minutes lunch break will be having, followed by Dr. Manoj Kumar, scientist. Will be sharing idea about building a network of researchers using InfluentNet sources. Then final session, very interesting, Dr. Ashok Rao from MIT giving details about resources for research funding. Then finally, we'll be having a discussion and shared by Dr. Rama Vaidyanathan, how further you can submit your feedback form to obtain the certificate from our university. All the details will be shared in that 3:30 to 3:40 p.m. that vote of thanks section. Please, I request all to listen carefully and make a note of all the sessions, and I am sure the sessions are being planned in such a way that any person can become any researcher can become successful researcher in future, with the motive of that our MGR University is taking this kind of initiative during this COVID-19 lockdown. And of course, I must wholeheartedly thank all the speakers for immediately accepting our invitation and being present for today to discuss about this topic. And I wish you all the participants very good luck and a great research future ahead. Thank you, Mr. Ganesh. Now the first session introduction. I request our sister admin, Mr. Ganesh Babu, to play the introduction video of a great eminent scientist and well-known academician, Dr. S.P. Tyagarajan, former Vice Chancellor of University of Madras and present Dean Research of Dr. Sri Ramachandra University, Chennai. I request Ganesh to play the video.
Ladies and gentlemen, it gives me immense pleasure introducing our speaker, Professor S.P. Tyagarajan, Dean Research and Professor of Eminence in Sri Ramachandra Institute of Higher Education and Research in Chennai. Professor Tyagarajan is a DSc in microbiology in addition to his PhD and MD degrees. He has put in 37 years of UG PG teaching and research experience in Tamil Nadu medical colleges and in University of Madras. He has also been conferred with several fellowship titles, including those by National Academy of Sciences and National Academy of Medical Sciences. He has till date completed 57 research projects funded by national and international funding agencies and mobilized grants over Rs 35 crores to the University of Madras. He has published 320 research papers and 16 books in the area of infectious diseases, especially hepatitis, STDs and HIV or AIDS. He is a member of expert committees of UGC, ICMR, DST, DBT, DOD, Ministry of Health, WHO, and so on. He has guided 69 students for research and 32 candidates have been awarded PhD under his supervision. He has conducted international collaborative projects with scientists from 26 countries, including USA, UK, Australia, New Zealand, Japan, etc., with mutual visits to these countries. His research contributions have been recognized by 21 international and national awards. Professor Tyagarajan is the inventor of a drug for the treatment of chronic jaundice called hepatitis B from the Indian medicinal plant Phyllanthus amaris kiranali in Tamil. He has also secured national international patent for this discovery on the name of University of Madras, and the patents have already been awarded in USA, UK, South Africa and North Korea. He additionally holds 3 more Indian patents. Some of his roles and achievements in the University of Madras: he's been a director, dean in industrial consultancy, registrar in charge, special officer development programs. While being a coordinator, he facilitated the 5-star level accreditation to the University of Madras by NAC in 1999 and also secured the award of University with Potential for Excellence status to University of Madras with a grant of Rs 30 crores by UGC in the year 2001. While being a Vice Chancellor, he spearheaded the 150th year celebrations of the university by securing a special grant of Rs 125 crores from Government of India. He conducted the 150th year celebrations inaugurated by His Excellency President of India and some other eminent personalities. Some of his roles and achievements in Sri Ramachandra University: while being a Pro-Vice Chancellor, he was coordinating organizationally and administratively the international and national level research projects ongoing at the university, funded by WHO, DST, DBT, CSIR and other funding agencies. He set up the Central Research Facility as a unit to cater for basic medical research, leading to translational medical research in the university under one umbrella, with an University Industry Interaction Center to facilitate R&D projects and clinical trials for biotechnology and pharmaceutical industries. Presently, he is a Dean in Research and Professor of Eminence of Sri Ramachandra University. He has a H index of 30, which is one of the most highest value, and he has a 2,648 citations and 132 publications. On behalf of Dr.M.G.R. Educational and Research Institute, we thank him and wish him good luck for his future endeavors in the field of research. Thank you.
So in this context, I thought of just interacting with you on the development of innovative ecosystem in Indian universities, which becomes all the more essential if you are venturing on research development in a university of international repute. I will try to tell you how it is important. Albert Einstein has said there are 2 ways to live your life. One is as though nothing is a miracle. The other is as though everything is a miracle. In research, every day is a miracle, and that forms the foundation for development of high quality research. We all know that life in academia is intertwined with research and discovery, not only for their own personal, professional career advancement, but also the institutional advancement as well as national department. It gives pride and excitement associated with being part of the scientific process, building up youngsters, building up departments, and building up universities. In the last 2 decades, there has been enormous pressure on the universities because of the importance that is being given for research and development and productivity from Indian universities. We all know that every university is wanting to get accredited by as many agencies as possible, as well as getting ranked by several ranking systems across the universities. If you look at the various kind of weightages that are given by the well-recognized ranking systems, you will see the academic ranking of World University Shanghai gives 80% weightage for research and research output, and about 60% weightage is given by the Times Higher Education World University Ranking. The QS World University Ranking gives 60%, and if you go for ranking in the Indian situation, the National Institutional Ranking Framework provides importance for 40%, and in NAC, which is just an accreditation agency, provide 25% weightage. What I am trying to convey is that the research has become one of the central stage for the institutional recognition and also projection in an international scenario. So if we have to really bring about high quality research, we have several domains that have to be put in place so that the desired ecosystem and environment is established in a university. For example, if we have to have a research development, then there has to be a unit which really facilitate this without any encumbrance or difficulty in an enabling environment. And then it has to also facilitate grants and funding through a unit which is dedicated for this purpose. And research governance is an exclusive entity asset which has to take up the initiatives of promoting research as well as making a kind of a friendly governance in order to facilitate research both among the faculty as well as among the students. Then there has to be a scholarly communication unit which has to facilitate quality publication initiatives, facilitating the publications, guiding the writing up of the publications and papers. And finally, you need to have a quality unit called Research Excellence Unit, which will be a mentoring, facilitating and monitoring kind of a unit in a university system. We will go through this one after the other. Let me start with research development. What do we say for research development? Research development is a set of strategic, proactive, catalytic and capacity building activities put together which are designed to facilitate individual faculty members, teams of researchers and central research administration in attracting extramural research funding. Today, without a research fund to be provided extramurally by various funding agencies within the country and outside the country, it becomes extremely difficult to bring about high quality research. And it is equally important also to create research collaborations and implementing quality research ecosystem. This is in a nutshell could be conveyed by the word research development. So you have several kind of research areas. N number of areas can be included depending upon the discipline in which you are with. It can range from basic research, applied research, fundamental research, R&D research, innovative research, product development, exactly. But all those really live on what is called a translational approach of research and development, where you are not going to be satisfied with a research that goes into the cupboard, but a research that goes into the field. And that is what is expected of an innovative research environment. Why it is important? We have been seeing that in the education has always been driving to bring about industrial reforms, and these industrial reforms through education has taken place through the research and development only. I don't want to elaborate on the various generations of industry revolution. Industry revolution 1.0 has resulted in steam power, weaving loom, etc. in 1784 and so on, followed by Industrial Revolution 2.0, where electrical energy from 1870 has happened. And later on, Industry Revolution 3.0, which resulted in the computer age, electronic age, automation age from 1967, has expanded the horizon of research arenas in a phenomenal way. And now we are in Industry Revolution 4.0, which is being completely governed by cyber physical systems, Internet of Things, networks, artificial intelligence, etc., etc. If we have to toe in line with this kind of international revolutions, we have to see that we are matching with the aspirations of the younger generation of people. Without elaborating on the earlier educational revolutions, we will concentrate on the present one, which is Education 4.0, which is expectation of the Generation Z. What is the Generation Z? The Generation Z is the generation of the present youngsters who are aged from 21 and above, as all of us know. Because the population of this Generation Z is about 40% of our country, we have to rely upon them to become productive individuals of the country, and hence our research aspirations, research development, and other facilitating factors has to be in tune with them. So Industry 4's evolution has become a kind of a development in the industrial sector which gets the kind of inputs from the trained manpower through the Education Revolution 4. And that is where you will see today the outputs like intelligent robots, autonomous drones, driverless cars, 3D, 5D printing, etc. in terms of technology. And then pharmacogenomics, bioprinting, healthcare products, applications of AI and others in instrumentation, diagnostic devices, all that are happening today. And so the synergy of science and technology in research is also becoming more and more important instead of a compartmental kind of a research program. And hence, we have to see that the environment that is built is able to facilitate this synergy of science and technology. So what is the important requirement? The important requirement is leadership for research. That becomes an essential feature for all the areas that we are talking about, just like, funding for research, collaboration, development, communicating your research, and also making a team to manage research and also conduct research. And all the other things have to be coordinated by a skilled leader. And that leader, in our opinion, is to be the Dean Research and Development of an university. I am focusing more on the Indian universities today, where we really require this kind of an environment creation and ecosystem creation in order to promote high quality research. This Dean of Research, who is going to be the R&D head, is an important person who will plan, who will monitor, who will also facilitate implementation of all the programs. And not only that, he or she has to keep track of the tasks that have been taken up and completed with deadlines. And then they have to facilitate necessary resources for this kind of R&D to take place, besides bringing in innovative new ideas for R&D, so that you will be able to facilitate the university to bring about breakthroughs scientifically and technologically. And so it is an important kind of a requirement, so that team building can take place at the appropriate time. Then we'll also have to locate it as A to Z gateway kind of a situation where a single point contact kind of a system has to be there, where every researcher in a university will be able to get their issues completely satisfied and the requirement are fulfilled, and for which it may be ideal to have a central research facility or a central kind of a setup in a university, which can not only help academically but also administratively. But then it will also be able to be provided with autonomy, the autonomy which is linked with accountability, both financially, administratively, as well as for the various funds that are received from various agencies. So this central research facility will facilitate the research planning, strategy development and implementation, project development, research fund administration, periodic reviews, and submission, including submission of project reports when the projects are completed, and as well as the utilization certificate and audited statements that are submitted to funding agencies on time. As all of us know, unless and until we are going to be financially sound and able to provide these audited statements in time, fund release from the funding agency is going to be of great difficulty and it will get delayed, and you may lose the funds for the next year also. So this needs to be facilitated, and besides, the central research facility will also have a overarching kind of a role in bringing about quality publications, patents, as well as technology transfer. This facility will have to have a sophisticated instrumentation facility which will try to help with the necessary infrastructure, an university industry interaction center, a consultancy and intellectual property rights cell, besides your own manuscript writing facilitating cell, and having a kind of a monitoring board, research advisory and monitoring board. It has been a good idea to have a research ambassador program in universities in the leadership development initiative, which will play a mentoring role for research. You may have a senior people who don't always look for their self-development, they always want an institutional development. Such people can be the research ambassadors for the universities and also research mentors who will go hand in hand with the active research ambassadors who make international kind of landmark contributions by way of their research and publications. And then the third tier will be the aspiring research ambassador, who are the youngsters who do hard work at the table and bring about laurels to the institution. This needs to be facilitated to bring about a brand awareness or to create engagement with idea leaders across the globe, as well as to increase the prestige and fast track the research visibility of the university. And it will also enhance the opportunity of the university for accessing to grant and global fund internationally. This will also help in getting international and national level university ranking if this kind of a environment and ecosystem is developed. So if we have a kind of an organization and leadership with responsibilities at the authorities, provision of resources, as well as communications without any gap, a quality policy can evolve, and hence a university should have definite research quality policies. The research quality policies can be the research promotion policy and the schemes that are provided by the university with the starter grants and other related financial incentives, and then resource generation and optimal utilization policy, consultancy policy and rules, intellectual property rights policy, innovation and startup policy, academic integrity and prevention of plagiarism policy, and publication quality and monitoring policy. It is always easy to develop policy documents, but what is important to see is that they are letter and spirit implemented and seen to be implemented among the youngest generation of the faculty members in a university system. And that has to be coordinated by the Central Research Facility and the Dean of Research and Development. So we can also have several other kind of user-friendly methods. And in a nutshell, if I have to put, you can promote research only from a bottom-up approach and not from a top-down approach, which means you have to see that you induct the aptitude and attitude among the youngsters to bring up research projects, get interested in research, and remove the bottlenecks and other hurdles they may face in developing a research proposal. May it be a PhD program under them, or providing a research starter grant, or providing them research fellowship to the candidates who are registering for PhD under them, and facilitating them to attend conferences, etc. These are all essential requirements if we have to promote high quality research. The infrastructure itself is an enabling environment. In science and technology, infrastructure forms an extremely important entity for high quality research to take place. We know now we are able to create a good level of infrastructure in many of our universities, which are able to cater to an equivalent situation and ambience to an international laboratory. But what is actually important is also that you need some kind of an innovation system which is available to you in the form of an incubation center. If an institution can also have an incubation center, there are enormous support to facilitate startups to come in as well. And if an incubator is positioned by the university, the possibility of attracting funds is also there. And that could be a way by which you can strengthen infrastructurally as well as through entrepreneurship development programs. One has to also see that we are putting in place all the national and international norms and guidelines. If people who are in the area of health sciences research and so on, there are several guidelines like the ICMR guideline, Drug Controller General of India guidelines, etc. And ethics is always there for any kind of research that you may be able to taking up. So these are another requirement that the Central Research Facility and the Dean Office has to see that it is facilitated. Then what is more important is an attitude development. We have to really induct a kind of an aptitude and attitude among the youngsters to see that they have patience and perseverance in developing high quality publications. They should not think that deadlines are the requirement for putting up publications. Many times it happens because their promotion is overdue for want of publications or to build up their academic performance indicators and so on. But then such of those publications are not going to really make a dent in the quality, but unnecessarily will be bringing down the quality of an institution overall. So that has to be taken up. Again, there is also another attitude that is there in the current generation, wherein people try to somehow publish the papers by making some payments to predatory journals. Predatory journals are spurious journals. They are not indexed, although they project that they are indexed. And that needs to be deterred by looking into clearly whether they are quality journals with its ACI impact factor, and we have to choose the journal while submitting the manuscripts. So these are some of the most important requirements for a growing researcher will be if he or she is able to make an impact factor journal article, and the reprints of the such researchers need to be sent electronically to extremely a wide range of researchers in the same area or similar area across the world. If that is sent, twin purposes can be satisfied. One, their own research publications may be cited by them in their future research programs and research publications. And you can also build up collaborations with them for future kind of international projects, as well as exchange of students and other requirements. So these are important besides maintaining research integrity and publication ethics while you are making publication. Avoidance of plagiarism is becoming more and more important today to look into that. Next important area is supervising PhDs. For a university teacher, supervising PhD becomes an essential feature. It is a passionate heart. You have to supervise with dedication, and this dedication will be able to aggressively promote the full-time PhD candidates coming to you. They know whom to select, and accordingly they will opt to come when they get a fellowship at the national level, whether it is DBT, if they have found that you are a passionate supervisor and you will be able to have quality candidates. The most important requirement, fundamental requirement, is every PhD guide should have a daily discussion with their candidates in their laboratories or workbenches, along with the workbooks or the e-workbooks. These are some of the kind of qualities one has to have, and we should also provide 24/7 researching facility for the PhD students. While adhering to the PhD regulations and others, it is important that PhD candidates are recognized as the promoters of high quality research in a university, and they are only projecting the research phase of an university, and hence we have to facilitate them by providing a 360-degree research ecosystem, and thus it will help phenomenally for the development of the institution. We may also have a strategic plan to make it, as everybody is talking, the postgraduates and researchers must be made to publish only in Scopus, Web of Science, IEEE, or PubMed indexed or UGC CARE list journals. And then we have to strictly adhere to the UGC regulations that are brought in from time to time. And we should also have good funding for developing the project. You are going to have another session, so I will not be going into the details of the grant generation, except to tell you that a grant is a mechanism by which an agency awards money to fund a research study or other activity, such as an educational program, service program, demonstration, or research projects. So this helps to project not only the institution, not only to acknowledge your idea, enhancing the prestige, bringing in financial health to a department and the university, it brings in international kind of collaborations, and hence we have to develop a professional growth strategy to write the proposals and build up our credentials. The most important requirement that I would like to underscore for any researcher to mobilize extramural grant is to see that they are able to look at the websites of the various funding agencies and their guidelines weekly once as a ritual. If you run through all the funding agencies that are available, you will easily be able to touch upon an area that you are researching in, and you may be almost certain of getting your grant through. That important, selecting an agency, selecting an area, and preparing a proposal becomes pivotal for developing your own kind of research capability and research grant. So let me tell you that research development ecosystem has to be ensured by 24/7 by 365 research culture. Time should not be a concern. We should never look at the watch when you are in a laboratory. The watch must be removed. No clock should be there in the laboratories, and the only deciding factor is the completion of the experiment that you have decided and designed for that particular day. Having said that, how do we really make it? Unless it may be nice to say and it may be nice to hear, but what is important is facilitating it. The facilitating that is called as research governance. Research governance becomes important because it includes professional conduct, research management, and also managing the finance and funding and resources efficiently and expeditiously. That is what is important. Even if the fund is there, if the governance system is not going to allow them to utilize the fund as and when they want in a user-friendly manner, you may not be able to have the research governance as required, which may result in slowing down of your research progress. So research governance concerns setting up standards to improve research quality and safeguard the public. It involves enhancing ethical and scientific quality, promoting good practices, reducing adverse incidents in the laboratories, ensuring lessons that are learned, and preventing poor performance and scientific misconduct. So all these are to be facilitated, and that can be done by implementing a software system in research management. A research implementation management system will be the best way to see that the entire process of research governance is transparently handled, expeditiously handled, and efficiently practiced also. If RIMS can be handled, then the whole thing may become leading to researchers' success. One side is research development, which I had explained to you already. We have to have skill development as well in the research development area in terms of grant writing, editing, publication writing, and so on and so forth. But on the other hand, the research administration becomes an extremely important area before the award of the project, after the award of the project, preparing applications for the grant writing, submission processes. All these are to be facilitated by the research administration or research governance. When both of them merge together, you will have the percentage of success enormously increased, and that will be the result of the synergy of research development and research administration activities. So catalytic leadership helps in bringing out curiosity culture, diverse teams, idea pathways, everything together, and that may help. One of the important facilitating factor in this governance area is to facilitate academia industry collaboration, because there is always a technology push that is there which we have to utilize, matching with the market pull that is there in the industry sector, and universities can act as lighthouses to bring in both together, and so that we will be able to be successful in satisfying the most often repeated slogan in India that we have to bring in intense academia industry collaborations. So if you see the market drivers, if you see the technology push drivers in the universities and R&D institutions are: universities require funds, universities have to conduct research and university laboratories, and you have to attract quality staff and students, and try to see that you are understanding the industry trends and try to bring about the requirements for them. In the same way, the industry also required an R&D strategic needs to as per the corporate style, and the universities have to satisfy the market and customer need and also match with the competition in time. That is what is more important that they require from the universities, not adhering to the 3-year tenure of projects. It may be monthly, by days, or 3 months, 6 months, and accordingly universities have to be prepared to do it, so that universities are able to get research support from the industry. They are able to bring about collaborative research for the students, as well as bringing in some resources to them. And thesis can be conducted by the students in a industry environment, by industry immersion program or internship program and so on. So knowledge transfer takes place. And finally, if this is built up in a big way, you will also be able to enable technology transfer that will be able to take place. So this also depends upon efficient governance. I was mentioning about research information management system, which is a synchronous flow as per the demand of the milestone and project deliverable that are there. It brings in transparency, expeditiousness, time-bound utilization of the received grants, accountability, and timely submission of the utilization certificates and audited statements. The manpower, needless to say, it has to be efficiently supported. The Research Governance Office has to be supported with quality manpower, with official decentralization of academic, administrative, and financial powers to the Dean R&D and the Finance and Accounts Division associated with that. Then what we want to have, that is innovation, can come up in a very big way. You will see that innovation is the buzzword we are talking today, which is including innovation, inspiration, creativity, analysis, technology, development, teamwork, success. Everything put together is the one that will create innovation. We are giving several kind of definitions for innovation. I would not try to look at it in detail except to see what is the important one is it has to work. It is not anything different, but it has to work and it start to be put into use. That is what is not just only invention, but it is to be put into use. So an ecosystem for this kind of innovation becomes important, which will lead into performance and value addition. And innovation with collaboration only brings about research and innovation ecosystem, and that is largely facilitated by academia industry collaborations, where there are several stages of innovation framework that needs to be undertaken by university. What is important is you need to build in the skills of creativity, you need to build in the skills of self-efficacy, energy, risk-taking aptitude, that is risk propensity, and the leadership. These are to be put together in your entrepreneurship development programs, and they are to be put together by means of collaborations. Research collaboration in so many ways. It can be collaboration between one PI and the other PI within the university, or interdisciplinary collaboration, intra-institutional, inter-institutional, university industry, NGO partnership, multi-institutional network and multinational network and so on, including public-private partnership. If that can take place, you will bring about commitment, competence, continuity and complementarity in it, finally resulting in output. So you need to have an ideal research and innovation ecosystem in higher education institutions. Many of our institutions, they do have some areas which are available now. For example, research knowledge and skills, creativity and motivation, research grants we are able to get. To some level of R&D governance may also be there. We have started putting in quality benchmark also. But from there only we have difficulties in assessing the outcomes on output, trying to protect our IPR, intellectual property rights, and then making financial kind of surveys, need analysis, incubators to develop products and all that, and then business offices for technology transfer. So these 4 or 5 steps are not there in our universities. That needs to be developed so that the cycle of ideal R&D, R&I ecosystem development can be facilitated. So for which only the startup ecosystem has come into being. It is effectively promoted by the Government of India and all the other areas wherein we should facilitate startups not only among students, it can also be facilitated among the faculties. Universities have to develop guidelines so that how a regular faculty can also launch a startup company. And that way they will be able to bring about this. For facilitating this, we need a university level entrepreneurship and business development model to be created. I will not go into the details for want of time except to tell you that we need to attract and young faculty entrepreneurs into that by doing workshops, by using some startup club like activities, social media use, bringing about consortium of the partners of the bio incubators along with venture capitalists, industrial partners, etc., so that we create an environment of developing the skills, knowledge, and attitude for this kind of a development. In order to facilitate only, government has come up with a policy in 2019, National Innovation and Startup Policy, which the universities have to adopt and implement them and utilize the Government of India initiatives of providing various schemes that I have listed here. Some of them are the DBT, BIRAC, BioNest Incubator Scheme, and Atal Incubation Center Scheme, TIFAC Core, which is not currently available, but the TBI scheme is there, etc. So these are some of the things that we have to see, and we should also identify what is the disconnect. We have localized area of skills in a university system. We have to connect them so that the desired kind of skill is brought out. So the bridging the gap becomes important, and that is where we have, I just thought that I'll project a case study wherein in Sri Ramachandra we have established an incubation innovation center with all these areas in mind, which are accredited, which are also certified, so that recognition is there by the user end, so that they will see a GLP certification or FDA auditing or CDSCO accreditation, etc., etc. But what is more important is, as I have told you earlier, you need to have a systematic, institutionalized entrepreneurship development scheme. You have to have a business management and support officers, a business development office, mentors and venture capital support, and a technology transfer office also, so that the entire cycle is completed and we will be able to build up that kind of an attitude. So for this, you can have any number of activities in a university which is commonly practiced. So you do have the entrepreneurship development activities that may take place. You can have the Institution Innovation Council of MHRD, AICTE, which facilitate youngsters to take part in them. And you must also have programs like innovation bazaars, hackathons, and others that can be organized for the students and young faculty to participate, so that idea generation takes place and you will be able to support it with the required kind of various infrastructure that may be there, either for development and so on. So let me just go in ideally to see that what is an ideal R&I ecosystem is developing a leadership, recognition of the right of an individual faculty, protected time to be given for the faculty. We have to put in some rewards, incentives for them, and user-friendly, innovative research governance has to be there. We should also see that facilities for startup companies to be established must be there, and quality technology platforms must be created. A brand value of the institution has to be created so that you will attract industry partnership. Hassle-free legal and IPR offices has to be there, and physical infrastructure to support the incubators and startup must be there. Above all, there has to be a research and development mentorship program in an institution. So it can also be facilitated by several other methodologies of setting up our industry R&D centers within the university campuses and so on. And I would like to only say that we should also have role models. See that local successful entrepreneurs and innovators are being called in to talk to the students and faculties, and then also see that the regions with similar attributes and resources are brought together. Successful organizations are made together. Even failure stories can be handled. And we must also have a quality monitoring kind of evaluation between the department, between the centers, and between the institutions as well. It is being practiced by developing quality radars. This is an international kind of an evaluation that I am projecting here, where introduction and diversity, research and development, commercialization, administrative requirement, and entrepreneurial cultures are taken in. And finally, let me end by saying research and development need to be handled in universities with tender loving care, commitment and courage, because more research will lead to more innovation, and this will lead to education 4.0 and economic upheaval for the institution as well as the country. Thank you very much. I will now take some of the questions with the limited time that is available. There are about 10 questions that have been given to me. I thought I will just say, take a couple of them, the next 5 minutes or so that you will have the break that is identified for you. What is the scope of research in India post-COVID pandemic? I would like to tell you my own experience that during the last 3 months, there has been enormous funding opportunities in Government of India funding agencies, both in DST, DBT, BIRAC, ICMR and other agencies have floated enormous kind of research calls, and only thing is we have to cope up with the speed of requirement. Even now some calls are there, so we may be able to do kind of research that is necessary. It need not be only in COVID-19 related hardcore area of medical areas or microbiology areas and so on. You can approach this in all possible angles to see what kind of thrust, what kind of new knowledge you can bring into that, and hence there is lot of research for it, not only within India but also internationally. We have to, as I told you, we have to look up the websites of the various funding agencies and really grab the opportunities for putting a proposal. The next question I thought I will take up is how to get funding support from international funding organizations. International funding organizations, they look into two important things. Number one, your track record of earlier work as evidenced by the publications of high repute. If you have got a chosen area of research where you have made a mark and it is evidenced by good publications, that is one basic requirement. The second requirement is whether you have already built in a kind of a contact with other people is also required, whether an international scientist you are in collaboration with. If both the things are possible, if both are equally interested in putting up to an international funding, then the chances of getting international funding will be much, much larger. The third and the final question that I will try to take is, can I work a novel pedagogy for research in MOOCs, since it has loads of future in the near future? I'm sure it is very, very important today. Whatever that has happened because of COVID-19, one good thing that has happened is enormous kind of role by online education, online programs, and other kind of technology infusion into the hardcore education. So we should try to utilize this opportunity, develop research tools in all stages of this kind of things through MOOCs. How to write a grant proposal, how to submit a proposal to a funding agency, how to write a quality publication, and all the other kind of areas can be developed for research in MOOCs, including technology. If you impregnate them with multimedia and other kind of real-time experiences, virtual realities, and so on, you can make the MOOC more and more sought after. And with this, let me wish you all the best. And I thank once again Dr.M.G.R. Educational and Research Institute for having given me this opportunity. Thank you very much.
Yeah, thank you very much, Professor Dr. S.P. Very good presentation. You gave us an overview of the research system that is needed in India. We have, I would also like to thank all the participants of this program. See quite a few joining us on the YouTube channel. Thank you very much for joining with us. We will have a 10-minute break. Before the next session. The next session we have Dr. Somashekar Seshgiri from Saigino Research Foundation. He will be talking about some of his research he has done in a very collaborative way on the ACE2 SNPs in the Indian population and its implications. So that will start at 11:10. So please stay with us for the next session. Thank you.
Shekhar sir, please wait for some time.
No problem.
Introduction video about you. Meanwhile, madam will give a small introduction and video about you. Then you please start, sir.
Yeah, okay. Thank you. But keep it very short. Don't.
Yeah. Just 1 minute video.
Yeah.
Madam,
thank you.
Are you ready?
Yes, I'm ready, sir.
Let us check Ganesh, then we will go live. 1 minute.
Good morning and happy to have all of you back for the next session. For the next session, the speaker is Dr. Sekhar Seshagiri, who is the president of Genome Research Foundation and the CEO of ModMap Therapeutics in the USA. He has recently published a paper on the human ACE2 receptor polymorphisms and the susceptibility to the SARS-CoV-2 disease. So we are extremely fortunate to have Sekhar here with us to discuss his paper and also talk to people about how collaborations work in research, especially at times like this. Yeah, we'll have a short introduction of Dr. Sekhar and then we will go on to the presentation by Dr. Sekhar. Thank you.
I feel elated to introduce the speaker of the upcoming session, Dr. Sekhar Seshagiri, the President of Science and Education, Genome Research Foundation. Seshagiri holds a Bachelor of Science in Agriculture and a Master of Science in Biotechnology from Tamil Nadu Agricultural University, Coimbatore, India. He is also a recipient of a Master of Science in Software Engineering from Golden Gate University, San Francisco, US, and a PhD in Genetics from the University of Georgia, Athens, US. He did his postdoctoral work in oncology and bioinformatics at Genentech. Dr. Seshagiri is co-founder and chief scientific officer for ModMap Therapeutics. Before that, he spent 21 years at Genentech, most recently as associate director and staff scientist. During his tenure, he established a state-of-the-art genomic laboratory, conducted research in cancer and cell signaling areas, and participated in drug development. Dr. Seshagiri leads SGRF's scientific research activities and is the driving force behind the Foundation's educational outreach activities, including conferences. He chairs SGRF's Next-Gen Genomics, Biology, Bioinformatics and Technologies, that is NGBT International Meeting. His research work has been at the forefront of understanding underlying genetic changes in cancer genomes through systematic identification of somatic mutations in large number of cancer types and subtypes using next-generation sequencing and other novel techniques. Seshagiri and team have applied computational methods and functional assays to understand the role of cancer-specific mutations in oncogenic signaling, leading to new target discovery of therapeutic intervention. He has authored and co-authored over 80 articles in peer-reviewed journals, including Science and Nature. We are grateful to have you in our midst for this faculty development program session. Thank you, sir.
Sir, introduction video is over.
Okay,
Shekhar sir, I think you can start.
Yeah.
Yes.
Yeah. Okay. Thanks. Yeah. Hopefully you can hear me. So I want to thank Rama in particular for reaching out to me and for this opportunity to share some of the work. I'm going to try and provide some context to the stuff that I'm going to share, but also try and make sure that some of the science around it comes out as well. So this particular research work started not too long ago, focused on the COVID-2 virus. I have a number of collaborators from throughout the world, and that was the theme which Dr. Tyagarajan started out with. In particular, I think there are many people that I am fortunate to collaborate and work with over the years in India. The foundation itself, MedGenome, that was fundamental to getting some of the data underneath or collating through their tremendous bioinformatics capabilities. And colleagues at the R&D labs at Genome, and also the University of Singapore, the University of San Francisco here, where I'm currently at, and also our small therapeutic company that is trying to make some inroads into treatment in cancer and other areas. One quick slide on the foundation, and then I'll get into the science that I want to talk about. It's a nonprofit foundation primarily set up with the idea of promoting science education. There are many nonprofits that do a lot of things, but I think, this has done an important work in the context of outreach and education, particularly scientific education and research. And also, it's done some work in creating healthy communities through applying science and society, and primarily operates on grants and some of the corporate social responsibility support. So is it visible now? Are you able to see it?
Visible, sir.
Okay. The slide visible now?
Visible, sir. Please
Okay.
go ahead, sir.
Sorry,
Please.
if you missed most of it, I'll try and be very quick. And I'm going to try and talk about the interaction between this SARS receptor, SARS proteins surface and the human receptor. And this Genome in Bangalore and the R&D center in Cochin, Genome. And we also have a small therapeutic company here in the United States, and colleagues from University of California, San Francisco, National University of Singapore. And clearly, science is collaborative. I couldn't do my science without collaboration. I couldn't do the science without contributions of many people well ahead of me in this world. So I'm very grateful for all of that, but I want to kind of tell you the story in the context of this evolving disease and what is being done. The foundation does a lot of work in outreach areas, and I won't belabor that as continues to educational conferences, and many of you have been there, at least some of you that I know. So I'll start with the themes here, which is
sorry, sir. Again, PPT is missing, sir.
Okay. I don't know. Let me see. So, if I touch the video, it drops off. Are you able to see it now?
Yes, sir. Now we are able to see.
I'll leave it in the mode, and hopefully everybody can see it. Okay.
Sure.
So, the history of modern humans is only about 200,000 to 150,000 years. Just a hominid tree. And in that time, we've all been, at least in this 200,000 year history, what I think most of us can fathom at best with our own mortality ahead is, maybe 100, 150 years, but look back in history, maybe a couple of thousand years, not 200, 150,000 years. But pandemics are not new. This is a diagram taken out of a beautiful cartoon that was put by a particular group called the Visual Capitalist. And what it's showing is, Yeah.
We are not able to see the PPT.
Okay. Maybe I'll try and not share my video. Hold on. Okay.
Benil ma'am, can you also mute yourself?
Let me turn this off. So, are you able to see it, Rama, now?
No.
Okay. I don't know. It just drops, I guess. How about now?
Got it now.
Okay. So I turned off the video. So let's see. Hopefully it works. If not, let me know. So slide is about pandemics and the history of pandemics developed by a group called Visual Capitalists. And the larger the little fuzzy ball, it's more deadly.
Put a red light there.
No, it doesn't.
Okay.
No, sometimes they're saying me instead of the speaker.
Quick.
And the rest of the people on Skype, mute yourself, please. Yeah, thank you. So what you begin to see here is there's a history of pandemic going back all the way to 165 AD. But majority have been probably bacterial. Some of it we don't even know what the cause is. And if you look at why we talk about these pandemics, as I said, 100-year history is as big as our memories can kind of hold. Rest becomes somewhat history. But the major bubonic plague in 1300s, and the smallpox, and subsequently that we talk about the Spanish flu, which was more recent in 1918. And the others, have been around, but in the context of the size of the impact of the population and how the virus and the humans have interacted and co-evolved and created sort of situations where a lot of people are eliminated. And the Spanish flu is one that we know a lot about, and then because science was much more ahead at that time. It infected over 500 million people, and the world population was about only 1.8 billion at that time. Still about 1/3 of the world was infected. And it took about almost 2 years for it to completely die down. I'll put this in context a little later on. And it resulted in close to between 40 and 50 million deaths. And over 12 to 20 million people died in India alone. That was British India at that time. The docks of Mumbai were the biggest source of the infection coming to the country. And all of this is to do with the human aspiration to travel, to trade, and move around. And the viruses and bacteria also come along. And that's why you have quarantines, you have all these checks, right? And we talk of social distancing, and that's nothing new. This was done during pneumonia. If you look at the bubonic plague, cities and castles would barricade, and people will let the disease die along with the people and not find new hosts. And that's the best tool we have at the moment, and that's what what is happening around the world. And it's remarkable. A place like India with 1.3 billion people, that it's an unbelievable sort of thing to be able to keep people indoors and prevent spread. And India has been fairly successful. But I put this in the context of history of science in particular. The first vaccine, 1796, Edward Jenner and Louis Pasteur coming and kind of evolving it. But they didn't know anything about DNA. We didn't solve the structure of DNA and didn't even understand the principle of inheritance and transmission until 1953. Of course, penicillin came and plagues were a thing of the past because antibiotics killed bacteria. But viruses are not susceptible to any of the antibiotics. And of course, newer drugs came much later. But the pace of science in the last 70 years has been remarkable. And I'll put this in the context of this beautiful little virus, but it's deadly. It's basically, Peter Medwer put it as saying it's bad news, a protein, bad news wrapped in a protein shell. And inside the shell is the RNA that's unsegmented, but it's 30 kilobases long, makes about 29 proteins. And this information is old. You already now have more than 3.5 million cases, 270,000 deaths across the world, and every country in the world has been affected. The history of coronaviruses in particular is not completely new, but you go back in time and look at historical facts, and there was no DNA test, there was no RNA test, but you do have material to go back in terms of written records, and also you can do molecular clock analysis using the sequence information. And what we understand from all of that, and this timeline chart here, we are right here, 2020, the MERS in 2012, the most recent, these are 3 major coronaviruses. There is at least 4 other coronaviruses that infect humans, and they're relatively mild. But using molecular clock analysis, you can go back and figure out these viruses have been around and co-evolving with humans. And it's a little bit of a yin-yang, and who succeeds and who kind of takes a backseat type of situation. So the history is 800 years, but you again put this in the context of human history, it's relatively very small. Yet we are profoundly affected by this little invisible sort of organism. And there is a clear understanding, and the pace at which science has moved. We know that these come from bats, which carry a lot of coronaviruses. The bat seems to be fine, but these viruses jump, and some of it is to do with human contact with animals in between. And also, we have gone from barely 1.3 billion in 1918 to about 7.8 billion today, and urban centers. And high-rise buildings and all sorts of things contribute to this stuff. And the reason the COVID-2 is particularly even more prevalent and is able to spread, one, we know from the initial data, it's only been 4 or 5 months of study across the world. The transmission ratio is 1 person on average transmitted to about 2.5. Whereas if you look at other stuff like the influenza or the MERS and even Ebola, it's a lot lower. Even though Ebola is more deadly. But on the other end are the measles and smallpox, and some of these we have managed to manage using vaccines or even completely contain them in a big way. So SARS is new, SARS-CoV-2. It's new in the sense it's not completely new, but yet new because the genome of this virus is a little different compared to the original COVID-2. What this is an evolutionary tree of the virus by looking at the genome sequence. There's a paper published in Lancet on January 29th, and we'll come back to that in a second. And what you begin to see is the new COVID is in this branch. But if you start comparing the sequence of the COVID-1, the first virus versus the current one, actually they're not that close. It's only about 78% or 76% identical. But it's more related to almost to a 98% to a bat virus, a specific bat virus. But when this paper was published, we didn't even know how this virus got into the human body, through what type of interaction. But we didn't know there are other COVIDs that use one of the receptors, proteases on cell surface, the ACE2, in the case of COVID-1, and the MERS that came from camels used another receptor called DPP4 or CD26. So this was blank. This was 29th of January. In fact, I was in India right around that time, and I had just come back, and I was reading up about these things. And I wasn't paying a whole lot of attention other than the fact that I knew this things were happening. And by then, the colleagues in China had already sequenced the genome, made the sequence available, and people knew it coded for about 29 proteins. And we knew from the experience of COVID, the first virus, a little bit of the biology. Between 29th and February 3rd, already there were papers appearing. There were also concurrent papers, which means people have been working on the virus pretty rapidly as soon as the sequence was available, to figure out how does the virus get into the human body? How does it get into the human cell? So the simple answer is the virus carries a surface protein called S protein. It's called the spike protein. It interacts with a human receptor called ACE2. It's an angiotensin converting enzyme. And this interaction is the key first step for the virus to get into the cell. So this data was coming out, and very quickly between January and mid-March, there were labs across the world that sequenced, that got X-ray crystal structures. I'm talking about how rapid the science is moving compared to when I told you the discovery of penicillin, the vaccines, the DNA structure. Now we're leapfrogging enormously in a very big fashion. And it's happening across the globe, and international community is sharing and interacting and providing information to see what we can do, how science can defeat this virus or at least contain it. And this all major papers, there are many that have come in terms of structure after this. And so this is a structural view on the left. This nicely created cartoon of the virus. What you begin to see is this the spike, the little red stuff that's sticking on the surface. That's the one that interacts with this receptor that I told you, the angiotensin converting enzyme. It actually sits on the cell surface, and it's expressed all over the body in many places, but more highly in our nasal passage. And now there is data even the virus can infect your gut. And this enzyme is involved in actually managing blood pressure. It's part of a renin-angiotensin system. It converts angiotensin peptide of a certain kind to another one that actually does vasodilation. So this has been intensely studied for the last 20 years or 25 years. But yet the virus basically cleverly co-opts this receptor and does things. So the data coming out as I was looking at this area, this is not something I work on generally, but it's an opportunistic thing. And you just ask a question, how can I contribute in the midst of this? And the only weapon I have in my arsenal is the science. And so we decided, a group of us said, hey, what can we do? We reviewed all the papers, and then we started saying, hey, there are people who are asymptomatic. There are 80% of the people seem to only have mild symptoms, thankfully. 10% get hospitalized. About 1 to 5% develop severe symptoms.
Shekhar, we just lost your screen. Can you check?
Sorry. Okay. Are you guys able to see it now again? Yeah?
Yeah.
Sorry.
You're fine.
You guys see this slide?
Yes.
No?
Yes.
Okay. So there is a big difference in the response to the virus. And about 1 to 5%, unfortunately, depending on the situation, develop severe symptoms and die. Some even develop kidney failure. It's not just lung. And there seems to be some population differences too, but I don't know how true this is. Partly when China had data and Italy had data, it was men seem to be more susceptible than women. And of course, rightfully, the articles attributed to men not washing their hands as often as women. And this gene is actually an X chromosome, X-linked, and men have only one copy, women have two, although only one is expressed. Age seems to be clearly a factor because young people, thankfully, are not affected. And there are other comorbidity factors, and we're all learning a lot about these things. So we simply started with the following hypothesis, which is the virus, the cell, the receptor, and the interaction between the S protein and this tuning fork like ACE2. A productive interaction and a permissible replicative environment produces enough virus. But there are people in nature, many of them might have a receptor that looks like this, and some might have a receptor that is even a better fit. And so the interaction is enhanced, and they're going to infect these cells a lot better. Those people carrying these natural variants are probably going to be more susceptible. People that have another form of maybe receptor variation that doesn't allow this interaction to happen very well are going to be less susceptible or even going to be resistant. A simple hypothesis is a cartoon I literally sketched out on a piece of paper, and then I called my colleagues in India and I said, look, this is an important and a very low-hanging, easy thing where we can make a contribution. And why don't we look at this variation? They said, yes, we'll come back. Meanwhile, other papers came out that basically showed COVID, the new virus. This is a sensogram of interaction. All the take-home messages, the new virus interacts a lot more. It binds to the receptor a lot more tightly compared to the COVID-1. And so that alone is a contributing factor. But there are more contributing factors, but this is one. And there are some protease site differences. We won't get into it in the processing, but the point is COVID-2 binds to the human receptor a lot more tightly than the COVID 2003 virus. And so that alone makes it, hang and get into the cell a lot more easily. So if there are alterations in the receptor that will alter your susceptibility, it'll be an important factor to understand. And so that's where we started. This is data from over 300,000 people. Again, this is the spirit of collaboration. This data comes from UK Biobank, the Nomad, the Genome Asia database, which there are many people that have contributed the samples to this, and their polymorphisms are in. Particularly, Partha from NIBMG and the colleagues at MedGenome in Bangalore, my colleague Ravi there quickly pulled all of this data. So this data from 300,000 people, we very quickly were able to figure out, there's a pie chart, but on the right is shown the variants that are relevant, because from the structural information, we know which residues interact with each other and form these bonds. And so that's marked here. We'll skip this and I'll tell you the context of this in a second. Next slide. So when we got this, we very quickly used structural information already available. Both my colleagues in California and there are colleagues in Canada, they quickly took the variants and mapped it onto the ACE2 structure. On the right, what you see, this big blob surface representation is the ACE2 human receptor. And these little black lines are the regions where the virus protein, S protein, interacts. And that footprint basically also leaves certain interactions that you can then place the residues where you find alterations in human population and say, well, if I change this residue to one of the other 19 amino acids, what will happen? Not only is this the footprint of COVID-2, there is some overlap in this footprint with COVID-1, which is slightly broader. And there is also another virus called NL63. It's also a COVID, but a different type of COVID. And that also shares this receptor. So at least 3 times in human history, there are 3 coronaviruses that have made sure actually are using ACE2 as its receptor. And this is not going to be the last time. Hopefully it'll be another 100 years, but maybe not. The virus and the receptor co-evolves. And so we can look at these variants that's shown again here in the linear diagram. This is the extracellular domain in yellow here. And these are 3-4 patches that actually make that interaction. So very quickly using this information, and there's also some other piece of data published by another colleague from University of Chicago that's in the bioRxiv. And by the way, our paper is in bioRxiv. It's not peer reviewed yet. So take it with a pinch of salt, but at the same time, we wanted to make it available to everybody as quickly as possible. And very quickly, my colleague Natalia and Divan and Fred came back and said, hey, we are seeing at least 2 distinct pockets. One where residue alterations might increase the risk, meaning increase the affinity of the viral protein, the S protein, that's shown in gray. And there are variants that are going to decrease that interaction. It's a very simple concept and very translatable. And so we looked at this data. They looked at the hydrogen bonding, the van der Waals forces, the hydrophobic interactions. And this does not need a lot of money. It only needs some time investment. And PyMol is in the public domain. The structures are in the public domain. And in fact, we started all of this work sometime probably 10th of March or 12th of March. By April 3rd, we actually had a paper and we put it in the archive. And that was only possible because of close collaboration with a lot of people. And in terms of what we spent, just our time. Other than that, we didn't spend any money. But luckily, then we were able to convince other folks to kind of join us and help with the science. And I'm just showing you a small laboratory validation that's still ongoing. Hopefully, we'll get it done in the next couple of weeks and the paper out for review. And what you're seeing is the COVID protein ACE2 interaction measured using an ELISA. And there are these variants I showed in the previous slide, and some, the lower the curve here, it means that it doesn't interact very well. But we see a trend between COVID-1 and COVID-2, but COVID-2 is already interacting much more strongly, even with variants that are predicted to confer resistance in the context of COVID-1. But COVID-2 seems to enhance, it still interacts better than COVID-1, but some of these mutants provide some level of relief or a decrease in the affinity. And in the right here, COVID-1, people know the transmission was through civet. And so we looked at the civet S protein. This is clearly not the intermediary host. There are other theories and ideas. I won't get into it. And there is a glycan in here, in the receptor at position 90, asparagine 90, from the crystal structure. This is discussed as an immune privileged site because there is a glycosylation motif. And this is again showing the S protein and the interaction between the ACE2. This is an older paper, but very well written. And there's a glycan that basically changes the interaction and might actually provide immunity. And there is a natural variant at that particular position, though very rare. There is a threonine at position 92 that will knock off the glycan at position 90 because this motif is required for glycosylation and N-glycosylation. And we looked at over 900 different animals, including humans, and we can actually figure out which ones, not only this motif in this interaction region underlined here, and we can build logo diagrams and start asking which animals are going to be susceptible to COVID, which can be a reservoir. And it's pretty clear our cousins, chimps, macaques, bad news, they're going to be infected. They might be reservoirs. They're probably going to transmit. We already know, people have shown that macaque and rhesus monkeys, the other models are being developed for this. And of course, you can go down and ask cats, other things, happens. So I think that basically is the story around this interaction, and we are still evolving this, but we have put out this data so national entities that sample patients, treat patients, and collect genetic material, DNA, RNA, and you can more elaborately study with this as one factor. And I'm going to just quickly end with a couple of slides here. I'm sorry, something happened here. Okay, so what I want to say is, how do we get through this pandemic? And that's the point of all of this work, right? And of course, social distancing is only practical up to a certain point. We can't live in caves forever. And hopefully, there are some intermediary solutions. One is going to be antigen testing, meaning testing for the virus using some simple tests. There is a race to develop a test that you can test people around, and I can get myself tested every day when I go into work. Physicians can get tested, students can get tested, and the reason is very simple. Asymptomatic people are the ones transmitting in a big way. And so if I know I am infectious, I can stay home and try to prevent infecting other people. And how do you do that? You got to test for viruses as rapidly as possible. The RNA tests take a long time. Okay, so then the antibody testing is the next thing to figure out herd immunity, and you need high quality tests. There is some confusion. It's definitely going to be important, and that's how you figure out, well, in the MGR University, anybody there is tested, and there's a large cohort of people that are resistant, which means they cannot transmit. And one of the things, if you look at the influenza pandemic, it took about a third of the world to be infected before immunity became the norm. So if you look at 7.8 billion people, the estimate is between 30 or 40% of people have to be either infected, or hopefully vaccines arrive, or maybe small molecule pills that we can take and manage. There are pills against influenza. I'm sure people will do it. There are a lot of people racing to do it, and there's antibodies and other ACE fusions. So that's how we're going to get through this. I'm going to stop here, but I just want to say again, my theme here is this is only possible because we could work seamlessly across the world, and particularly I'm grateful to all my colleagues in board here in India, without whom we could have not done this. And I'm going to stop there. And Rama, if there's anything else that I can add to, please let me know. And I'm going to stop. And thank you again for the opportunity to share our work.
So, and you can, since we are short on time, you can take a pick.
Yeah.
One of them want to know when can we, would we be able to predict whether somebody is a carrier or going to be susceptible? How soon would that be with the age?
So I think, so let me again share this last slide very quickly to. But very simple, right? If you go back up and if you look here, there's the only option right now is staying home, right? But many people are asymptomatic. So you need a viral antigen test that can be done non-invasively in 15 minutes time and should cost maybe no more than 20 rupees or 100 rupees, right? And India can innovate. A lot of the people out in the world are innovating, and Dr. Tyagarajan spoke before about innovation. And the government of India and the Department of Biotechnology, BIORAC, they put out a lot of money. And they are trying to motivate people to do. And Rama, you and I exchanged some emails about biosensors.
Yes.
And I think people should, take this very seriously and work 18-hour days to kind of make things happen. It's possible. And so I think in less than probably, I predict 6 months, we're going to have antigen tests that people can use in a very rapid fashion. And that's one development that's going to happen.
Yeah.
And we have the tools, and people are working feverishly across the world, not just here in the US, but in every part of the world.
Yeah. Okay. Yeah. Thanks, Shekhar. So,
okay. Thanks.
A couple of other questions, maybe we can take it. Yeah. So there is one question about, of course, the BCG vaccine. Do you think it really helps? Then somebody wanted to know more about the NL63 virus.
Yeah. You can, NL63 is a very mild virus. It's the alpha coronavirus. It uses the same receptor, but its spike protein behaves a little different.
Very much, Shekhar, for your time. And for the viewers, we will give you the email ID of all of the speakers here so that you can communicate with them. Yeah, thank you, Shekhar.
Thanks, Rama. Thanks, everyone. Appreciate your patience and listening to my talk.
Yeah, next we have with us Dr. Shakti Pandey, who will talk to us about more of the nitty-gritties of preparing a research proposal. Thank you, sir, for coming here.
Yes,
so there is an introduction to Dr. Shakti Pandey through a video. I request Mr. Ganesh to screen the video.
Ladies and gentlemen, it gives me great pleasure in introducing our speaker, Dr. K. Shakti Pandey, Associate Dean, R&D Cell, Setu Institute of Technology.
Introduction video about Dr. Shakti Pandey, sir. Ganesh?
Ladies and gentlemen, it gives me great pleasure in introducing our speaker, Dr. K. Shakti Pandey, Associate Dean, R&D Cell, Setu Institute of Technology, Kariyapatti. Dr. finished his PhD in Material Characterization in Anna University in the year 2013. He completed his MPhil in Spectroscopy in Imperial University in the year 2007. He completed his MSc in Physics in Madurai Kamaraj University in the year 2005, and he finished his BSc Physics in the American College, Madurai in the year 2003. He started his career as a lecturer in Erode Arts College in the year 2005 and worked there till 2007. And then he moved to K.S. Rangasamy College, where he worked for 1 year. And from the year 2013 till date, he is working in Setu Institute of Technology and is currently Associate Dean. Some of his research experience: total research grant received is 81.97 lakhs. Total number of publications, journals only, is 66. Cumulative impact factor published is 109.69. Maximum impact factor of a paper is 9.048. Cumulative impact factor under review is 21.55. Number of ski was journal is 61. Number of invited talk given is 30. Number of conferences he attended is 115. Dr. Shakti Pandey has made enormous and innovative contributions to materials characterization using online ultrasonic techniques and other conventional techniques. He received many laurels and awards from the National Scientific Society. He was a co-author in 3 research books. Dr. Shakti Pandey has attended more than 120 national and international conferences in India and abroad. Under his able guidance, 2 scholars have completed their doctoral degree and 4 scholars are pursuing their PhD degree. Presently, he is working in the areas of nanoferrites from electromagnetic shielding and developing nanoparticles from herbal plants for biomedical applications. On behalf of Dr. M.G.R. and Educational Research Institute, we wish him good luck for his future endeavors in research. Thank you, sir.
Yes, sir. First of all, I am thankful to God Almighty for this opportunity. I am also thankful to Dr. M.G.R. University for giving this opportunity. I am also thankful to Dr. A.C. Saran Kumar sir and Dr. S. Manivannan sir, who is the backbone of this program. And I am also thankful to the VC of this university as well as the Channamal madam for this opportunity. In this presentation, we will little bit know about the introduction and what are the research component and what are the layout of the research proposal and what are the various funding agencies and various fellowships available in India and a small conclusion about the research. We know research is nothing but a searching of knowledge, careful consideration of a study regarding a particular problem. However, the various definition, one definition is very famous. The research is a systematic inquiry to describe, explain, predict and control the observed phenomena. That is the one of the well-known statement for the research methodology work. The characteristics of the research. Research can do by some of the logical reasoning, some of the data work, but however the way we have to follow some systematic approach. The rules and the procedure should be followed for each for the research work. If you change the dimension of the view, you can get the better results. For this picture, see this is the first picture, that man has some hair. If you change the dimension, you can see that man has, there is no hair. Usually in the research methodology class, one story was famously telling, 5 blind people are going to see the temple. They are seeing some of the elephant in the temple. One person, all are blind, so one person came out and he told that the elephant is like a pot. One person will come, say it is not a pot, it is like a plate, like a moving plate. And the third person is coming like it is a rod, not a pot. And the fourth person will come out and saying that it is not a rod, it is a small rod, but the bottom is not fixed, it is movable. And fifth person will come and saying that it is not a rod, it is like a thin wire, it consists of so many pairs, like that they are saying. But all are the characteristics of the elephant, but their views are very different. Like that, one can do the research in different ways. The type of the research means we can do some of the basic research, applied research, problem-oriented research, problem-solving research, and qualitative and quantitative research. So any kind of research we can concentrate. So Dr. Dhyarajan sir has mentioned about the various advantages of the research. So I skip this slide. So what are the component of research is paper publication and research awards and fellowships. That are only the 40% of the research. If you publish some of the books, book chapters and research project, that will cover the 80% of the research work. If you want to 100% of the research means you have to develop some patent, you have to do some consultancy work. Then only the research will be completed. So before the application of any funding agency, we have to create some of the IDs that are essential for the to know about us from the funding point of view. We have to create some of the IDs like a Google Scholar ID, Scopus ID, Web of Science ID, Mandali and Bablan and Vidwan. So Google Scholar, we know Google Scholar is one of the search engine. It provides the broad way to search scholarly articles. We can search our thesis, article, books, everything we can search from the Google Scholar. In addition to that, the authors can track their citations about their publications. And also it will give some H index. H index is nothing but if you publish a high quality of paper in high quality of journal, then it will give the H index. H index is nothing but the number of citations received for the researcher for their publications. If the 10 papers get the 10 citation means H index is 10. So minimum H index is needed for applying any proposal. If you have that H index 10 means they will surely consider your proposal for evaluation. So H index will gives another one of this distribution of the citations and your impact of work, that will give the H index. Another one ID is ARCHIT ID. ARCHIT ID is some unique ID. It is a 16 digit characters ID for each researchers and scholars. Like a mobile number, they are given some numbers. So, for example, T. J. Kumar or A. Senthil Kumar, these names are very common. So, the common names means we have coupled the publications may be overlap. In this way, we have to identify the person by some unique number. That number is called as ARCHIT ID. It is also free. So, ARCHIT ID connects the publishers, funders, society and university and other research and other research entities. That is, once if you get the ARCHIT ID, then you can add your publications by your DOI numbers. Then the funding agency may know you how many publications you have published by the person. So if you put a T.J. Kumar means so many publications will come. Instead of the name, they will use the number. So in this flower, each rows are identical. So if I say the roses, everything is roses. So if you identify the each rose by the number means we can get some IDs. That ID is called ARCHIT ID. So this I already explained. This ARCHIT ID connects the various type of the grants to society membership. Now the Web of Science needs ARCHIT ID, or some of the publications need ARCHIT ID for paper submission also, manuscript submission also. In future, the grant application should have the ARCHIT ID. The professional society membership is also needed, this ARCHIT ID. And it also displays your CV and your web pages. It will give some more visibility and publicity for you. And Web of Science is also similar to the ARCHIT ID. Here also you can add your publication, track your citation. The another advantage of the Web of Science is you can create some alert. You can save your searches. If someone is working in a image browsing, you can create some of the searches and create alerts. Whenever the papers related to image processing or your keywords is published, it will intimate to you that paper is published. Like that, we can create some alerts in Web of Science. Whenever you are going to write a review paper or some literature survey for your project, at the time you can rerun the search. What kind of work has been done so far, that it can be carry over from this Web of Science. It is also ID. It has one alphabet and 8-digit number. And another one is Vidwan. Vidwan is nothing but it is the initiative of our Indian government by Ministry of MHRD. They are also giving some ID for each researchers. This is my profile. One can do this. Hello?
Yes, sir. Please continue, sir. Your voice
Yes,
is
sir.
missing. Yes, sir.
Yes, sir. Just a minute, sir. Just a minute, sir.
Okay, okay. Please. Sorry.
Yes, sir. So this is the MHRD profile of the Vidwan. Here you can find the author profile. How many authors, how many publications we have published so far, how many co-authors are there, the names of the co-author. If someone is published with me, for example, Indra Devi. Indra Devi is also published with the paper Sindil Kumar and also Siva Bharati, like that we can predict. So this is a co-author map that will be the one of the efficient. Here you can add the personal information, your expertise information, experience, education, qualification, honors and award. The doctoral thesis evaluated by you or the supervised by you, the professional body membership, the membership committee. Another one is the research product publication. Everything you can add. In addition, MHRD connect all other academic ID like Archit ID, Scopus ID, Researcher ID, Google Scholar ID, and Microsoft ID. So this is our Indian government initiative. It is one of the advantage of the importance of the Vidwan profile. So I request all the viewers to create the Vidwan profile. It will give the more visibility to the government about you. And funding. Generally, funding is has a three component. One is the planning, writing, and follow up. Planning means first you have to identify your area of research and find out the research gap by the fellow and researchers. What are the works have been carried out so far? That you have to list. You have to carry out the exclusive literature survey for the your research work, and then you have to identify the research gap and formulate your idea to the proposal. So after that, the problem, you have to think about the background of the problem. What is your problem statement? What is the solution? What is the identity of the outcomes and sustainable of the solutions? That also we have to plan for the problems. Another one, as Dayarajan sir has rightly mentioned, that you have to visit the funding agency website. Frequently you have to visit all funding agency website like DST, AECT, DRDO, ICMR, like that. Identify the relevant scheme for the proposals. That is also another important. These are some of the components like executive summary, project background, problem statement, goals and objective, and beneficiaries. These are some of the things we have to plan initially. In addition, we have to plan about the proposed methodology, what is the budget, what is the scheduled activities, when the project will be started, what are the works we have to carry out in a time. So the time chart we have to mention, and monitoring and evaluation also we have to do for our research problem, and we have to justify the sustainability of our solutions. So this slide shows that the different component of the project. One is the idea. First, if you have idea, then you have to look about the vision of the funding agency, whether your idea will be matched with the vision of the funding agency, and what is the documentation needed for the funding agency, what is the deliverable data needed, what is the budget they can allot for our project. That also we have to think, and what is the ratio of the acceptance for the project. Another one is dipolymer is a word represent the different component of the project proposal. One is title, introduction, here I mentioned that, problem statement, objectives, literature survey, methodology, and reference. That is called as a dipolymer. The title of the proposal, introduction, and problem statement, objectives, literature survey, methodology, and references. In addition, the title of the grant, referee, scope, applicant, budget, other operating heads, non-scientific abstract, summary of the research, details of the research proposal, and application CV are the important ones for the project proposal. The title, title of the proposal will be very concise. It gives some attract to reviewer or funders to fund the proposal. So we have to identify the titles in attract way. Some newspapers will do like that. If you see the front page of the newspaper, the title will be very interesting and attractive. Like that, we have to put our title proposal is very interesting way. The title should not be very long, and you can put the more technical title, and very short title also sometimes gives the wrong result. And referees should be taken like that. You have to choose the referees in your field of research. Choose a scientist or colleague. That will be the objective, but do not critical of the science. The only thing you have to choose the expert in the same field. If you choose another expert in another field, means they may be wrongly understand your proposals. And only things to not choose your collaborators and your friends and your earlier colleagues. So nowadays we can predict how you are connected with each person. The author's map will show how the co-authors will be connected. So do not choose the close collaborators. In the same way, you don't choose the top level scientist in the field. They may be not respond. Sometimes they will critically comment your proposals. And the same way, you do not choose the competitor in the same field. And co-applicant should be the strength of the proposal. If you choose the right co-applicant, means they may consider your proposals. If you choose the wrong co-applicant, means that is the biggest weakness of the project proposal. Generally they will reject the proposals. So budget also you have to consider. The budget should be taken in a correct way. If you each instrument cost should be specified in a correct manner. So other operating heads should be clearly mentioned. So avoid the overlap of the heads in the budgets. Generally, the people will prefer the non-scientific summary. You have to use the non-scientific summary as abstract. If you use the more technical abstract, means they won't consider your proposal, because the person working in reviewing your proposal to assign the reviewers, that person may be wrongly understand your proposals. So the summary of the proposal should be very short and informative and background to justify your research. If you have the background in the same area, means they will consider your proposals. Okay. Another one is the aim is also very important. In the aim, we have to specify 2 to 3 aims. Don't put the more aims, and do more address the feasibility of the work, and do not write more aims, complicated aims. Risky aims should be avoided usually. Another one is applicant CV. In this application, list all your awards, especially the awards directly related to the research, and list out all the publication in the last 5 years. Sometimes you can include all the publications. You have to mention the impact factor of the publication and ranking of the journal also in this publication list. If there is no evidence for the publication, means they won't consider the proposal. All middle author publications should maybe rejected the proposal. In this case, if you are a corresponding author, you can represent and the corresponding author proposal.
Yes,
sir, please.
Excuse me, Sakipandi sir. Sorry for the interruption.
Yes, sir.
Please finish in 5 minutes, sir. Then please
Yes,
answer
sir. Yes,
for the
sir.
3 questions, sir. Sorry for the interruption, sir.
Okay, sir. Usually the strength of the proposal should be carried out at least the primary level. Some case study or prototype model is expected. The tangential result should be obtained. Deliverable is very important for each proposal. And know about the evaluation procedure of the project and prepare the proper presentation for the evaluation if it needed. Expect the best results from this. So many funding agencies are there: AICT, UGC, CSR, DAE, BRNF, DST, ACRB, DRDO, Ministry of Environment, Department of Biotechnology. So many funding agencies are available for the sciences, and social science also so many funding agencies are available. So each funding agency has different schemes. Each scheme has some vision. If your project proposal objective should be merged with the vision of the proposal, that is the ultimate aim. So this I want to say that which funding agency is interested in your funding of the study, that should be you have to understand it. So the next one, you have to think and write the proposal. If it is declined, you can try again, you can submit to another funding agency. If it is funded, you can give the treat to your colleagues. Again you have to think, again you have to write the new proposals. So the only way is you have to think in different ways. Instead of taking a stone and putting in a pot, you take a straw and take the water out. That is the easiest way. Thank you, sir. Thank you.
Yes, sir. Thank you very much, sir. Few questions that we have posted from our persons who are attending. Kindly
Yes,
answer,
sir.
please.
Yes, sir. How can we explore ourselves, sir?
Yes, sir.
Yes, sir.
Please answer, sir. Those questions
yes, sir.
you would have received. Yes, sir.
Yes, sir. Basically, the key points to make the research proposal and funding agencies are available to help the funding agencies. Generally, it is depend upon the PA age. If the PA age is less than 40, means you can go for a ACRB with the startup teams. If your age is middle age, means you can go for a Kiran scheme with the DST. The key point is only the objective aims and significance of the proposal. The significance of the proposal is the last chance to impress the reviewer. Do you think the interdisciplinary research is more trend? It's more trend and the difficult as well. Nowadays the interdisciplinary and transdisciplinary research is very important. There are two schemes in University Grant Commission for the interdisciplinary research as well as the transdisciplinary research. In this transdisciplinary research, the science person we have to collaborate with the social science arts person. So the people, the UGC will expect the proposal like transdisciplinary. How to check the plagiarism free of cost? Some of the plagiarism software online is available, but don't go for this. Sometimes they will track your material. So free of cost is really difficult nowadays. The method of applications of the data analyst in research. Please add a note in free tool of software. Hello, sir. Which component of the research proposal decides its approval? Only the two component. One is your aim. What is your proposal aim? What you are going to solve, and what is your capability of the completion of the project, whether you have the prototype model or you have the sustainable publications in this area. How to write a best review paper. Nowadays it is easy to write the research paper. There are so many tools are there, like you can go for a Web of Science, you can create a alert, you can collect the materials for the same topic, you can easily write the review paper. What are the main precautions for the successful collaboration in research? Once if you publish so many papers, other countries or other researchers in the same field, they will definitely contact you. You have to publicize your work in the ResearchGate as well as the Mantley, Babylon, like that. You have to publicize your work.
Hello.
Yes, sir.
Yes, yes, sir. Excellent, sir.
Thank you, sir.
Do you have any further more questions to answer, or can we wind up, sir?
Yes, sir. I finished, I think, sir. All questions, sir. Yes, sir.
Okay. Thank you very much, sir. I request Dr. Rama Vaidyanathan Madam to propose vote of thanks for Dr. Shakti Pandey, sir.
Yeah, thank you very much, Dr. Shakti Pandey. That was an
Dr. Rama Madam, please.
Extremely good presentation. So I'm sure our viewers would have learnt a lot from this. Next, we have with us Dr. Venil Sumantran, who is a scientific advisor to the Dr. Abdul Kalam Center of Excellence at Dr.M.G.R. University. She is also an accomplished researcher, and we will, there is a small introduction video, and after that, Madam will give her talk. So,
hello everyone. I take immense pleasure in introducing the speaker of our next session, Dr. Venil Naranan Sumantran, Scientific Advisor, Dr. APJ Abdul Kalam Center of Excellence in Innovation and Entrepreneurship, a part of Dr. MGR Educational and Research Institute. Dr. Venil Sumantran has completed her PhD in the field of biology and biochemistry at Virginia Polytechnic Institute and State University, USA. She has also pursued 2 postdoctoral fellowships in University of Michigan. Dr. Venil is a senior researcher with 22 years of experience in top-ranked universities and research organizations in USA, Europe, and India. Her research expertise includes cancer biology and advanced biochemistry, molecular basis of diseases, biochemistry, and instrumentation. She was principal investigator in USA NIH-funded research at University of Michigan. Her work experience spans across prestigious institutes like University of Michigan, Gothenburg University, Vision Research Foundation, and IIT Madras. Add her credits, Dr. Venil Sumantran has published 43 papers in peer-reviewed journals, 3 book chapters with H-index of 20, and citations above 1,500. She regularly reviews on BIRAC, SIBRI, and big grant proposals. Dr. Sumantran has developed in vitro assays to evaluate anti-arthritic activity of selected Ayurvedic drugs on human osteoarthritic cartilage. This work has produced 1 patent and 7 papers. At the behest of Dr. M.G.R.
you can start speaking now. We will all be going mute now.
Good afternoon, everyone. I hope you all can hear me. The talks so far have been very interesting. So for the past 10-15 years, I've been doing independent research on a low budget, and I want to talk about how to be the best researcher you can be. Not getting the next slide. So why do I think you have to do this? Because if you are the best researcher you can be, others will automatically want to collaborate with you. It's easier said than done, so I'm going to talk about what the obstacles may be in your path. I'll give 2 of the strategies for novel research that I have tried, and this really requires a small budget, so I hope it will help you. I'll also talk about why you should give your research an insurance policy. I'll explain that. And then finally, it's very tough to be a researcher. And maybe with the post-COVID-19, it may get even tougher for a while because funds may dry up. So you have to recharge your interest in research. You shouldn't give up. So let me begin with a Hindu newspaper article last year, which talked about the problem of copycat research. So there was a vice chancellor from a university in South India who said that the university faculty are urged to discourage irrelevant research, and in many state universities, the research topics are often repeated. So we know about this, most of us, The PSA to the Prime Minister also added some points in this article by saying important basic questions in your chosen field must be tackled, important applications must be developed. Now, obviously that's true, but I would like to dig a little deeper and see why we have these copycat research problems and what other problems we have. So these are some of the obstacles that I have faced: lack of funding, lack of trained manpower, lack of infrastructure, lack of time to read, develop good ideas for research. And let's be honest, there is also fear. I've come across this particularly in India. Fear that someone may steal your research idea before you have time to work and publish it. And then last but not least, the fear of trying something new. And this has been my problem for many years. It's much easier to keep doing the same assay over and over again and publish papers. Trying something new requires guts and some risk-taking ability, and the earlier speakers have talked about this. So, having looked at these obstacles, what can I add that might help some of you? I'd like to talk about low budget research. I admit I don't have answers to all these obstacles, but by doing some low budget research, you can publish some quality papers. So that's what the next few slides will talk about. So one of the low risk strategies that I've used in the past 10 years is to identify a well curated database which has free data sets that can be analyzed with simple software or software that you can learn. Now remember, there may already be publications from this free data set that you choose. So read carefully, find new questions that these publications did not, and then reanalyze such data with your original questions and hypotheses to get a good paper. Now this is not a risky strategy, but it requires a lot of patience, willingness to learn, and a tenacity to keep at it. So let me give you an example of how this particular strategy worked for me and a group of MGRU students about 5-6 years ago. So we started with a free data set on gene expression in normal skin versus skin from melanoma cancer patients. Before getting into the data set, I had read melanoma literature, and it was exclusively on the gene markers for diagnosis and treatment. Now, as a biochemist, we all know that skin has a property of giving us a waterproof barrier. Why? Because it contains a lot of fat or lipid. We also knew from cancer research that cancers have abnormalities in fat metabolism. So our team at MGRU, we reanalyzed this data set for genes regulating fat metabolism. And we got some interesting results. We found specific fat metabolism genes and pathways were significantly activated in the melanoma skin compared to normal skin. And we were quite surprised that this was the first such report on melanoma worldwide. Why hadn't anybody else thought of looking at fat metabolism in skin? I'm not sure. I'm not a genius, we were not geniuses, but we asked an interesting novel question on a pre-existing free data set. So if we can do it, anybody else can do it. That's my point. Another strategy that I have used, this was in Pune in the early 2000s, apply an inexpensive technique to a new research problem to get some novel data. So I was given the charge of a grant where we were looking at different Ayurvedic herbs for activity. This was a grant from CSIR and the work was done in Pune. And Amla and Ashwagandha are two herbs with very similar properties. And I asked the simple question, how can we distinguish between them at the cell level? I hope you can see the picture of the Amla fruit and the Ashwagandha plant on the right. So what we realized when we looked at the literature is that very few studies simply measured the effects of these two herbs on cell growth. I wanted to try that. I took two methods for measuring growth. One is the very popular MTT assay, which really doesn't measure growth. It measures cell survival, but it's a short-term assay. It's easy, reproducible. And the second assay was the colony formation assay, which is usually done in soft agar for cancer cells. We modified it for Chinese hamster ovary cells, and we did it on plain tissue culture plastic. This assay really measures the division of one single cell into multiple cells, which then form a colony. So those of you who do bacterial work, you'll be quite familiar with a colony assay. So this colony formation assay can be done with mammalian cells too, and it takes longer. And it's important, very important, I think, because it measures long-term growth. So we had an MTT assay for short-term growth and the colony assay for the long-term growth. Now let's look at the results we got. Fairly interesting. So here you see in 1A and 1B, two 6-well plates. 0 simply means that no drug was added. Under 0 you see triplicate wells and fair number of colonies of the CHO cells. In 1B, on the right, we added 50 micrograms per ml of the amla extract. Not much difference in colony number. In 1A, we have 100 micrograms per ml of the extract. Maybe a slight difference, but we counted individual colonies, looked for statistically significant differences. There were none. So we were fairly confident. We repeated this experiment many times with different batches of amla, and we never found any inhibition of colony formation by amla, which is called Nellikai in South India and Aula in North India. Now, Ashwagandha gave us very different results. So here you see 3 6-well plates. Again, 0 means no drug added. In all the 0 labeled wells, you can see a good number of colonies. And if you look at 2C, you can see 25 micrograms per ml, 2B, 50 micrograms per ml, and 2A, 100 micrograms per ml. The point is fairly clear that there's a dose-dependent inhibition of colony formation by the ashwagandha extract. So using the MTT assay, we never saw any difference between amla and ashwagandha. I have not shown you that data. But on the colony forming assay, we got completely different activities for these two herbs. And our Pune team's publication is one of the very few reports showing that ashwagandha and amla can have very different effects on long-term cell growth, not on short-term cell growth. So with these two examples, I've shown you how you can ask interesting novel questions and get good publications in decent journals without much of a budget. The third point I wanted to cover was the idea of an insurance policy for your research. That may sound a little strange. What I mean is, if you get a project from a funding agency, please do 2 to 3 types of independent experiments in parallel. Why? Because if one fails, chances are the other one will succeed and give you some good data. So again, going to my Pune experience, we had to test certain Ayurvedic grants for anti-arthritic activity. We actually did these experiments on cartilage from the arthritis patients who were undergoing surgery. So we would actually go during the surgery, collect the tissue, keep it sterile and work on it. We did 3 types of experiments on cartilage cells as well as the cartilage matrix. Here's just a picture to show you a piece of cartilage matrix, and you can see tracks, and within those tracks you can see the small cartilage cells which are called chondrocytes. So the first experiment was, can any Ayurvedic drug improve the survival of these cartilage cells from these arthritis patients? We got very variable results. The cartilage cells would quickly become fibroblastic, and basically it became a big flop. The second experiment was, can any Ayurvedic drug slow down the loss of cartilage matrix from these samples? And we did get some successful data. We compared it with a positive control, glucosamine sulfate, and we could then get publishable, statistically significant results. The third approach, we didn't use any cartilage from the patients. What did we do? We actually bought 2 commercially available enzymes which can degrade cartilage matrix. One is hyaluronidase, the other is collagenase. We set up simple assays for these enzymes. And again, we found that some Ayurvedic drugs would inhibit these enzymes significantly, and we could get reproducible data and publish. So I've shown you the 3 types of experiments and how they could give us a patent and good research papers. If we had only done the first experiment on the cartilage cells, we would have nothing because it flopped badly. So this is the idea of the insurance policy. Please don't have one type of experiment. Please have 2 to 3 independent experiments which will give you a better chance of getting publishable data. At least this has been my experience. I'll go back for a minute. I should say that all of this work was done over the past 15 years. It's a very tough, frustrating journey. Many researchers would agree with me. And often I would face this problem where me and my team, we have a lot of activity, but where is the productivity? So it's really important for researchers to find ways to recharge themselves, just like we do recharging of all our mobile devices. You know, now you're staying at home in lockdown. Find ways to rekindle your interest in research, because it can be a lonely and an unrewarding career many times. Let's be honest about that. So the next few slides, I just want to tell you how I try to recharge myself. It's harder for me in a sense because I work alone, mainly from home, independently. I don't have people who I can regularly discuss with. So what do? I find that if I'm constantly doing computer work or administrative work, it definitely decreases motivation for research. I've seen that in some people around me, and when they get a break from all of that and they go back to the lab and spend hours a week, just a few hours a week doing experiments, they get refreshed. So this is one way to avoid the burnout that we face. And your students will definitely respect you a lot more. I remember my PhD advisor would constantly be purifying enzymes, working with equipment, and we had tremendous respect for him. He would come in on a Sunday morning and work. So please remember that stay in touch with your technical work for a few hours a week. The other thing is you have to force yourself to learn new things and apply them for your research, whether it's computer skills or a new assay or some new programming that you have to learn, or even entrepreneurship, innovation courses like we are doing in the Kalam Center. You have to upgrade yourself in different ways. That will enrich your research. Start interacting with other departments. Don't be in a silo by yourself. It's a small group discussion, a small journal club, whatever it is, start in a small way. It will definitely benefit you, your students, and it can lead to a very good collaboration sometimes. So another...
Please in 5 minutes, please try to finish, madam.
Yeah, I'll be done.
Thank you. Sorry for the disturbance.
So the last point is about recharging your interest in research. It's very important to read, keep reading related and unrelated topics. The reading will sharpen your mind. You can ask good and relevant questions. Also review papers in your field or discuss them in journal clubs. It will give you ideas, solutions. You may even find a collaborator through that approach. So the main point is reading and reviewing is tremendously important for recharging yourself and getting good papers and grant proposals. So my summary is, these are some of the strategies that I think you need to be the best researcher you can be, and you can try them out. They will help you improve your publication record and then hopefully attract better collaborations. Thank you very much. This we can skip. Yeah, so stay positive and thank you.
Thank you. Thank you, madam. Excellent session. You have really made the session very awesome. Excellent presentation. We could see the excellent positive responses from YouTube viewers. More than, at present, more than 700 plus participants, and the like is exceeding 400 to 500. Thank you. I request Dr. Rama madam to post questions on
a lot of questions, but I'm going to just restrict myself to just one. How difficult was it for you to learn about microarray analysis when you did, and how difficult is it for you to convince students to learn the same?
I found it very difficult because I was scared of computers, statistics, and I still have that fear to some extent. I must say there was a professor and a student who helped me a lot. And then I kept working from home, making mistakes, nobody saw them. So that gave me some confidence. And frankly, it's been easier to teach the younger generation. I think they're much more interested in using online tools. So I find they're enthusiastic, but they also have a weakness in statistics. And so that's the only problem. They're enthusiastic and they are catching up much faster than I did.
Thank you, ma'am, for a wonderful talk. And all of us can see how passionate that you are about research, that you still continue with your research. Thank you, ma'am.
Thank you.
Excellent. Excellent, madam. Chief guest is Dr. Rama Vaidyanathan. Madam is a Director R&D working at our Dr.M.G.R. Educational Research Institute. She is heading Abdul Kalam Research Center. I request our sister admin to play introduction video about Dr. Rama Vaidyanathan.
Okay.
Ladies and gentlemen, it gives me immense pleasure in introducing our speaker, Dr. Rama Vaidyanathan, Director R&D of Dr. APJ Abdul Kalam Center of Excellence in Innovation and Entrepreneurship, and a Professor in Biotechnology Department in Dr. M.G.R. Educational and Research Institute. Dr. Rama completed her BSc in 1987 in Botany from Sri Venkateswara College, University of Delhi. She then completed her MSc in 1989 in Biotechnology, School of Biological Sciences, Madurai Kamaraj University in Madurai, and she completed her doctorate in 1998 in Biotechnology, Center for Biotechnology, SPIC Science Foundation, Chennai. She started her career as a Junior Senior Research Fellow in Center for Biotechnology, SPIC Science Foundation from 1989 to 1998. She then worked as a postdoctoral fellow in University of California, San Diego in USA from 1998 to 2000. She then worked as a faculty in Amritanjan Private Limited, Chennai from 2003 to 2004. Then she was a head in the Department of Biotechnology in Dr.M.G.R. Educational and Research Institute from 2005 to 2015. From 2015 till date, she is a director in Dr. A.P.J. Abdul Kalam Center of Excellence in Innovation Entrepreneurship, Dr.M.G.R. Educational and Research Institute. Some of her research experience. Her research at Dr.M.G.R. Educational and Research Institute is focused on studying mechanisms operating in antibiotic-resistant bacteria and identification of new compounds against these bacteria. Her research group focuses on developing high-throughput assays for identifying molecules against multi-drug resistant bacterial biofilm formation or antibiotic efflux. They also focus on next-generation sequencing technologies to understand methods of evolution of antibiotic-resistant determinants in bacteria. The other focus areas in the center include bioprospecting microbial biodiversity for industrial uses. Some of the projects have been funded by the CSIR and DBT. The research group also has consultancies and collaborations with industry. Dr. Rama has guided 6 research scholars for their PhD, and she has over 15 publications in international research journals. Dr. Rama joined the Entrepreneurship Educator course conducted by the National Entrepreneurship Network (NEN) in the year 2009. She has attended advanced workshops offered by NEN on design thinking, finance, mentoring, and scaling up. Dr. Rama is the coordinator of the Entrepreneurship Cell of the university since 2007 and presently coordinates a DST New Gen IEDC incubator in the campus. She has been instrumental in launching the Vadwani LearnWise courses in entrepreneurship in the campus. The New Gen IEDC has funded 25 student project prototypes, of which 2 have been selected for funding under Startup Nidhi Grant of Government of India. Membership in professional bodies. Dr. Rama is recognized as a regional mentor of change by Adal Innovation Mission from Government of India. She is a member of the Inner Wheel Club of Madras Midtown, Chennai. She is a lifetime member of Indian Biophysical Society and a member of All India Biotech Association. She has a H index of 8, 573 total citations and publications of 18. On behalf of Dr. M.G.R. Educational and Research Institute, we would like to thank her and wish her good luck for her future endeavors.
And thank you very much to Dr. Manivannan for giving me an opportunity to speak in this development program on building collaborations in research and innovation. Yeah, collaboration is the key to good research. That is something that we all know. The second speaker of the day, Somashekar, showed us how...
Madam, you can share screen also.
Oh, the screen has not come?
Yes, madam. Please share the screen.
Yeah.
Thank you, madam.
So let me... Okay. Just a second. I have the PowerPoint ready, but I think, yeah. Yeah, are you able to see? Is the screen seen now?
Yes, madam. Visible. Kindly go ahead, madam.
Okay. Thank you. So, yeah, so let me start with this. The collaboration is key to good research. We have seen a lot of examples. And this morning also we saw a talk by Dr. Sekar where he was able to get a lot of research done by collaborating with a few people. So my talk today, will be for about 25 minutes. I will not keep you away from your lunch. Why should we collaborate and types of collaborations? A few examples from my experience and how we can plan our own collaborations. So obviously, the first reason as to why we collaborate is when we write a project for funding, the funding agencies ask for collaboration. So recently there was a a call from the stars, and you can see there that it says they want to promote an interdisciplinary and translational research, and they would definitely prefer uh, projects which are interdisciplinary in nature. Why does that happen? Because people believe that faculty with different and complementary perspectives, knowledge, experience, that results in innovative approaches to problem solving. We have seen some examples today. There is an expanded capacity of research. The same data on the number of people affected by COVID, you can see the way different groups have presented it. On the right hand side top, that's how the Johns Hopkins has presented. And down you see the Worldometer, they have presented it in a table. And the Ministry of Human Resource Development has presented the same data in a very different way, depending on the expertise and what is the audience that they are catering to. So this is an example where there are different aspects for the same problem. The other advantage of collaborating is the possibility of handling large number of study subjects, and you can conduct research across disparate locations. The other reason is to collaborate is to share some expensive equipment or some important technical expertise. Citing another example that we've seen recently is Serum Institute of India is extremely good at making vaccines. So Oxford University has collaborated with them and asking them to make the COVID vaccine. And when you collaborate, we all share information much faster. Here is one example that we've seen in this COVID times is the MEDEX and BioRx papers. These are preprints which are not certified by peer review, but these are very important because it tells you what others are working on, and it can also tell you what may not work. And it was very nice to see that Indian scientists have deposited about 53 coronavirus sequences in a public database. Before COVID, usually people would not deposit the sequence immediately, give some time until they write up a publication and then only deposit. So you see that there is a much more sharing of collaboration now, sharing of data when you collaborate. The other advantage of collaborating with someone is that you get criticism early. If you made a mistake, your friend is likely to point it out. You can also have a division of labor. There can be a group of people who are collecting data, some who are compiling it, and some who are analyzing it. Okay, I just want to share a small example with you on a success story of a collaboration. This happened long back when I was a postdoc, and this was basically the work of my boss at US. So here is a paper which has 13 authors across 3 countries, across 6 institutes. So how does this collaboration work? So a very short background, I will not fill you in with too much of biology. All of us know that for crop productivity, you need to provide a lot of potassium. The NPK fertilizers are given. We also know that sodium is bad for crop productivity. Now, plants share the sodium and potassium transport mechanisms. But can we do something to modify the plant transport so that plants becomes very smart and they don't, even if there is sodium available, they don't take up sodium but only take up potassium? That would be a smart plant. So the lab that I was working on, Schroeder lab at UCSD, had already, a lot of people around the world had this idea. They were looking for a transporter which would be so smart. They had picked up a transporter which was called HKT1 from wheat. And they wanted to do several experiments, and it's easy to do experiments in Arabidopsis compared to others because a lot of people collaborating. So they had some very specific questions to ask. Where is this HKT1 gene getting expressed? Is it only in the root? Present. So, Julian Schroeder looked around and saw what was it that he could use. So there was one lab in Wisconsin which had a collection of knockouts. So he could write to them and ask them to give some samples of the Arabidopsis seed. So in Arabidopsis, you have to do your own screening, then go back and tell them which is a pool you're interested in, get the pool back, and then you can self them and screen and pick up the knockouts, the plants in which this is not working. So he wrote to them and he got some seeds. Then he wanted to find out what was the level of sodium in the different plant tissues. So he found somebody who was working effects of this mutation on plant growth. So there was somebody who was given this job. The most important of this was, does the mutant, the one in which this gene is not working, does it have a phenotype? Does it do something differently? And that was the most important question in this case. And what does all of this data mean? That is also the most important thing. And that was the job of Dr. Schroeder. So he did this experiment, and that's what, each of the authors in this paper was given one of the questions to work on. And once all this data came out, they did, the person who found the phenotype did the most critical work because he had to do a lot of experimentation. And this was the paper which was published, and they found that this gene is important, but maybe not very important in Arabidopsis, but likely to be very important in rice and other plants. So this was a paper which was published in about a year's time, and there were so many people who were working on this. So this was something like you've seen an orchestra. The principal investigator was like an orchestra director. There are a lot of 13 different people who were working on something individually, but together it makes a lot of sense. So Dr. Schroeder was able to put together all of the data and explain what was the role of HKT1. He was able to show that the level of sodium in the root was very low, but it increased in the shoot. So maybe this means that when the HKT1 is not present, there are other transporters which become more active. And he also showed that the plant ultimately does not do well when this gene is not present. And he was also able to get a lot more collaborations because he knew that in monocots this gene was more important. So I gave this as an example because here is an expert who already has an established lab, has a network, and he already has some data. So he can build on known data, use whatever resources that he has very effectively. He has a very clear objective. There are very clear questions that he is posing, methods, and there is a role for each of the collaborator. So this is like an expert collaborator. This sort of collaborator doesn't happen overnight. It evolves over time. Just when we start playing a computer game, we don't immediately log in as an expert. We start off as a beginner, then after we have some experience, we understand the rules of the game, then we become an intermediate, and then only we play as an expert. So if we start logging into a game, and instead of putting in as a beginner, but say you're an expert, what happens? You will complete the computer game probably within 3 or 4 seconds because you don't even understand the rules of the game. So similarly with collaborations, you need to start practicing as a beginner, then go on to intermediate, and then work as an expert. So when I say beginner, I think, intra-institute collaborations where you work with a peer, a colleague, faculty colleague in the same department, or a faculty from a different department, faculty and students, etc. Those are like a beginner level. An intermediate level would be an inter-institute or an academia industry collaboration, and then you go to the expert level of international collaboration. So let's look at some of these basic collaborations. When you are a PhD student or a PhD mentor, it has a responsibility of choosing a research question, planning a methodology, providing a lab infrastructure, chemicals, etc. The student's responsibility is to read up, plan and execute these experiments. Then they start analyzing and interpreting the data. The guides help them do it until they are able to do that independently. So you need to interpret your data and plan what your next experiment is. So sometimes, the guide will choose a journal and tell them, this is the journal in which I would like you to write a paper. And the last two steps, the student keeps doing until they are able to do it independently. So this is the first collaboration in research, the collaboration between the PhD mentor and the student. So you start doing this. Then you can also have a faculty-student collaboration. When I mean a student, I mean a graduate student. So in my experience, students like a BTech or a MTech student are with you for about 3 months' time, and they need to get a present paper, a thesis ready. So you can't give them something absolutely new. So what works best is when you have something which is robust and repeatable, and you have an experiment where you need to collect a lot of data where the assay is robust, then you can ask students to do this. You can train them and get some data out of them. So we had success in one such work, but we also found that the students who were doing this, though they were just project BTech students, they were so involved in this work that they continued to work with us even after the BTech thesis was done. So this is a faculty-student collaboration which many of us can work with. So I know that there are a lot of students who have registered for this program, and student-student collaborations are also very good. And I've seen that happen when students participate in hackathons or apply for the IEDC grants or choose an open elective subject to learn so that they can interact with other department students. And sometimes meeting over extracurricular activities. So all of these help in building student-student collaborations. So looking for innovative ideas. Most institutions today have mandatorily an Institute Innovation Council, and they all of them give advertisements for asking for innovative ideas both from students and faculty. So we also do that. We have a funding from the Newgen Department of Science and Technology's Newgen IEDC fund, and we can fund about 20 projects per year where we can give 2.5 lakhs to each of them. And this is just for an idea which has a commercial potential, and we can create a prototype out of that. So we give these advertisements, and we get a lot of ideas, but there are very few which actually are completed because the faculty also needs to have a commitment to convert the idea into a prototype or a business plan. I will just share 2 examples. This was an idea that a faculty in the School of Physiotherapy had in our university. So there are already some foot dynamometer and equipment which can find out what is the strength of muscles in the hand. So she said, why don't we do this with the foot? Because there is a need. There are patients that I have with whom I need to measure the strength of muscles in the feet. So she had the idea. There were 3 students who were interested in this, and from the sketch to convert it into a prototype which works, this required a huge learning curve for the students. So one of the students in particular, Bharat Kumar, though he is a physiotherapy student, he actually sat and learned Arduino programming and electronics, and he actually built this equipment from scratch with the help of one of our managers in the IEDC. So an important thing to convert an idea into a prototype, you need to have a commitment to learn across disciplines and convert it into a product. Another innovative idea that a student came up with came out of empathizing. So again, the physiotherapy department were empathized with patients and said that there is a need to convert a wheelchair. We should be able to convert that into a stretcher whenever we need. So these students, again, Sabari and Dinesh, worked across their disciplines, learned and created this prototype, and they worked so hard. So this is extremely important, learning across disciplines. The intermediate level in collaborations is to learn how to work between academics and industry. Because we know that one is from Mars and the other from Venus. So how do they work together? So here's an example. So one of my colleagues, Hepzibah, so we had to attend an InflibNet conference in Ahmedabad. It was mandatory from InflibNet. We had to go there, and they wanted us to make this digital thesis much more popular with the PhD students. So we said, let's do a survey within our university, find out how aware students are, and then we will look at ways by which we can make it more popular. So we did this survey and presented this at the InflibNet Congress in Ahmedabad. And one of the sponsors for the program was ProQuest, who's an international company which works with ETDs. So they looked at our paper and said, oh, this is very nice. Why don't we repeat this survey with a larger audience? And that was a collaboration that we worked with, and Hepzibah continues to collaborate with ProQuest with similar research. Another example of an industry academic collaboration was a chance meeting with an industry CEO who found out that I was a biologist, and he said he's has a chemistry industry, and he said, I'm looking for some process improvement. Why don't you come and visit the industry and give us a feasibility report? So I and my colleague went to the industry, visited and understood what was the requirement. Then we signed a non-disclosure agreement, made a preliminary proposal. Then we had a lot of discussion on what was needed, and then the money that was needed that we wanted. So we had several discussions, and finally we came upon one agreement. So what I learned from this academy industry collaboration was, first, we need to establish what is the know-how of both parties. What does the industry say that they know? What is the information that the academic parties say that they know? And what is the knowledge that they are going to create? Have very clear milestones and deliverables. The payment terms. Sometimes there's an exclusivity agreement, and we had to sign a paper which said that even 3 years after completion of the project, we will not reveal or work on a similar project. But it was a very good learning for us. We could understand the differences in the working of a lab versus industry. So that was extremely useful for us. So that is an example of a collaboration which works well. So I know that all of you are looking at how to build your collaborations. So if you want to collaborate, first thing to do is establish your profile first. What do you want to solve? So the research question that you ask is most important. And then the approach that you are taking, how is it different or better than what others are doing? And is there a way you can scale it? And is there a translational potential? These are some questions that you need to ask. And what are your skill sets? Why are you better than anybody else? And why do you want to collaborate? What are the skills that you're looking for? What do you have? What do you don't have? And that is what you're looking for. So these are something that you need to look at. Then what are the expectations from a collaborator? So I think, if there is just a single contact, when you're just writing to somebody to ask for one strain, biological strain or some resource, or they just give you an idea, that is usually an acknowledgement in a thesis or a publication. But when you are asking for a regular contribution, repeated resource sharing, an intellectual contribution where the collaborator, you want them to do a data analysis, interpretation. Sometimes you might require them to be a member of a PhD doctoral committee. I think that qualifies for a co-author in a publication. And if you're comfortable with this person, then you decide that, and there is a suitable call for grant available, then you decide that you want that person to be a co-applicant for a grant. So how do you start looking for collaborators? So I think we need to look for a collaborator with a complementary skill.
Pardon me, Dr. Rama, madam.
Yeah.
Madam, can you finish in 5 minutes, madam?
Yes, sir.
Thank you. Thank you. Later we can have questions. Thank you.
So you can, sometimes you need to look at publications which are of interest to you. You can contact the prospective collaborator through ResearchGate, email, meeting at conferences. So you need to write an email to the prospective collaborator very clearly. So here is an example that I have. So this was a collaboration I was seeking for with a collaborator in Norway. I have never met him earlier. I wrote to them that I'm a professor from Chennai. This is my publication list. I just gave the ORCID link and asked whether he is interested, because there is a call for grant which is available. And these are the themes for the call for grant. What do I do? What can I do? And what will be the effect of this? And would you be interested? So I had already done some homework on what he was doing. If he is interested, we could have a Skype call. So this was an email, and we were able to apply together, but we didn't get the grant. But this is an example of how you can approach a collaborator across countries. So let's assume that you have identified a collaborator and you are going to write a grant. So there is a session later, I think, which will teach you how to write. So usually the principal investigator is responsible for communication. He is accountable for regular recruiting and purchase, etc. And co-investigators usually have specific milestones, deliverables, and timelines. And it always helps if you can do some preliminary studies. And I think, in a collaborative grant, it's better to focus on HR, recruiting researchers, rather than focus on equipment. The challenges that we face in collaboration, one, I think Dr. Vinil was also talking about this. A collaborator listens to your idea. He's very excited, then goes back and writes back saying that the management refused permission. Then he might apply for a grant separately, though it was an idea you developed together. Yeah, it can happen. So the solution would be, don't reveal your idea until you get some written confirmation that they are going to work with you. An idea is not enough. You need to do preliminary studies to find out whether it is worthwhile or not. The other challenges that we find is, you write a collaborative grant, you get the funding, but one of the collaborators, for some reason, who was doing extremely well, is unable to participate and continue. So that can happen. So the solution is to document your meeting with collaborators, ensure clear objectives and milestones. And it's important to get a commitment with the collaborator's boss for committing time on this project. So we can say 2 days a week you need to spend on this project. So I think that helps in continuing collaborations. There is really no foolproof guide for seeking collaborations. I am reminded of a saying which says, the harder I work, the luckier I get. I think that is very important. You need to keep on trying, practicing, and I'm sure you will become successful. So if you have any questions, I can take them over email. This is my email, and I'm sure there'll be some time at the end of the session at around 3:30. Thank you.
Thank you, madam. Wonderful session. I wish to read a few comments of our participants in YouTube. Mr. Amit Arora has mentioned, very effectively organized and intellectual lecture. Thanks so much, MGR. Then really going good than any other online FDP. Even MHRD session got broke in between, sir. I don't know, but really happy that we are doing good. And nice arrangement, Dr. M.G.R. and Dr. Abdul Kalam Research Center and its entire team. Thank you, madam. A lot of positive comments are pouring, and at present, more than 700 live plus 7,000 and recorded are being available at YouTube. Few questions I wish to ask on behalf of participant. Does collaboration and MOU are same, or is there any distinct difference between them? Collaboration and MOU.
Difference. MOU
yes,
is just a letter of saying, okay, let us agree to talk to each other. But collaboration is actually doing something. So when you are a collaborator, you need to know what the other person is looking for and find out how you can work together. It needs a lot of work. It's not just one-time letter signing. So I'm happy that we've been having a continuous collaboration with Dr. Vinil and also with Dr. Manoj Kumar, who's a speaker in the afternoon session. We've been having collaborations over a period of time. And I think that speaks well for our university.
This could be an opt question for this season, madam. COVID has locked us down. So how to 1 minute, madam. Impact of COVID-19 on research system. Impact of COVID-19 on research system.
Okay, thank you. So
then how do you manage research activities during lockdown?
Yeah, so it is a challenge, of course, because
yes.
It is a challenge because as a biologist, we are unable to do wet lab experiments. We are not able to go to the lab and do experiments. But the other thing is, we can use this time to learn capacity building. So all of us together, actually, my lab, we are all learning data visualization in R, and there are a group of us learning BioPython. And I also keep telling myself, there was an article that Mr. Narayanamurthy had written that Indians must be ready to work 60 hours per week. And I think we all need to work extra hard once we get back to the lab so that we can make up for the time that we've lost for wet lab. But I'm very sure that we are all going to learn much more, do a lot of capacity building. And I think the research environment after COVID would be slightly different. I think there will be a lot of focus and on grants for COVID-related activities. So we'll just have to think innovatively and see how we can get a piece of the cake, so to say.
Yes, madam. With this positive comment, we wish to finish our session. Mr. Sai Kumar wrote, this is the first most productive day in the past 2 months. Hearty appreciations, madam.
Thank you, and same to you. So you are as much a collaborator in this.
Yes. Thank you, madam. Almost time is 1:10. We will wind up for lunch break, and sharply 2 o'clock we will meet again. Thank you, participants, and please be back. And our guest is almost in Skype call, and he is at any minute he is ready. We can request him to be in live. So participants, please come back sharply at 2 o'clock. We will begin our session. Thank you.
Thank you.
What we do here is go back. What we do here is go back. What we do here is go back.
To all the participants out there, and thank you very much for your very kind comments. So we are enjoying this workshop as much as you are, and I'm very happy to have the next speaker with us, who is a senior scientist, Mr. Manoj Kumar from InflipNet at Ahmedabad. So I would request the technical, the system admin to give us an introduction to Mr. Manoj Kumar with the help of a video, and then we will get on. We'll meet Mr. Manoj Kumar.
Somebody left.
It gives me an immense pleasure to introduce the speaker of the next session, Dr. Kumar. The speaker is a senior scientist in InflipNet Center, Gandhinagar, Gujarat. He is heading the award-winning project Shodh Ganga, a national repository of theses which received many awards. He has completed Masters in Computer Application from Kerala University from India, and he is currently pursuing his PhD in Semantic Web in Gujarat University, India. His expertise are in computer science hardware and architecture, which includes digital library, multimedia, web services, programming, RFID, library management software, e-journal consortium. He has more than 25 years of wide experience in information and technology, 5 years service in Indian Institute of Management Kurikuri, 1.5 year experience each in Coal India Limited Ranchi as System Officer and Assistant Engineer in CEDTI in Calicut. He was guest faculty in Gujarat University for MTech in Networking Tech and dissertation, faculty of MSc IT for 6 years in Rolwala Computer Center, Gujarat University. He has won E-India Jury Choice Award from Mrs. Smriti Irani, former MHRD Minister. He has received the coveted NDLTD Leadership Award from Washington DC, USA in 2017. He also received the EduShine Excellence Award 2019, presented by Sri Suresh Prabhu, the Honorable Minister for Commerce and Industry and Civil Aviation, for emerging institute promoting government digital initiatives. He has published 30 and has co-authored around 80 papers in national and international journals and has also edited 4 books. He is an expert committee member in many universities. He has delivered expert lectures in 90 universities, which includes 4 IITs, 5 IIMs and NIFT Delhi. It is great to have you here, sir, for the Faculty Development Program. Thank you.
You can start the session, sir. Sir?
Manoj sir, you can start.
Manoj sir? Manoj sir, is it audible to you?
Manoj sir?
Manoj sir, please unmute your mic. Please unmute your mic, sir.
I'll call him.
He started speaking, but he didn't.
Unmute.
Hello.
Yes.
Yes, I am audible now to you.
Yes, sir. Please, sir. Please go ahead.
So good afternoon, everybody who has signed on to listen to me. Manoj Kumar from InflipNet as the introduction. Thank you for the kind introduction and the beautiful video you have made. I'm sorry for using mask because I'm talking from the Ahmedabad, Gujarat. Ahmedabad is almost becoming a Wuhanabad now, with the number of cases increasing, and Gujarat is having the threat about. We have reported about 390 cases in 24 hours, and that is a place where when India is touching 60,000, and majority of the cases are from Ahmedabad, and I am in the peak center of that. I cannot move out. That's why the habit of wearing the mask is still there. I just take it out for the sake of giving this lecture for 45 minutes. So welcome to the session. Thank you very much, Dr. Yama Madam, and the pupil who has given an extensive thought for delivering online lecture in this period, which we have already initiated. InflipNet Center, MHRD and UGC has already initiated various ways, and I hope that there will be more people joining. And how many people are there before I switch to the PPT?
500, sir.
500. That's good. Wonderful number. Now I will switch over to the PPT part of my presentation, and this will be regarding the activities online. Especially I prepared for the lockdown period and the post-lockdown.
And you know that it is completely locked down, and here it is 7 days complete lockdown. Even shops are closed, grocery shops are closed. So that is a time when I am talking to you, and this may continue further, maybe in a lighter way. Maybe we have to go with this virus, as you mentioned in the morning, that there is no way. So our learning and research is going to be online. That is the indication which I have to start with, that not only in 10 days or in this lockdown, it will be the way which we are right now doing. That will be the same way to continue maybe for 1 year time, or more on online, and the teaching and learning will move towards the online. So let me share the video, the PPT. I just want to get feedback from people because I'm not seeing. Is it my screen is visible now?
No, sir. No, sir. Please share the screen, sir.
Now is it?
Please wait, sir. There is a delay. Yes, now your screen is visible. Please go for PPT. Yes, sir. Now visible.
Yeah. This is the introduction. Challenges in the building, collaborations in research and innovation is the topic chosen by Dr.M.G.R. Educational and Research Institute. Once again, thanking you for that. And wherever my audio is going down or video is not perfectly matching, let me know that if there is an issue. You can just give me a call on my mobile if I'm not listening. And research and innovation, both are equally linked together. The research becomes innovative when you put more effort and novel ideas into research. And when you are going for the new ideas, where from you will get the resources? So we have been listening to many people in this forum, in this online webinar talk from morning onwards, starting from our beloved Vice Chancellor Tyagarajan Saab, and research. All of them mentioned about this, doing research online and the importance of it, and how that should focus on the society. This is what in nutshell, I understood from the morning sessions. So research and innovation should lead to something which will be useful for the society. And that will only happen if innovative ideas are coming to that. And when you have an innovative idea, when you have something to do as a research or to learn more, what are the sources or resources where we should focus upon, and how we can improve the learning and research skill. That will be the base of my talk today. And I am from Influminate Center, which she has already mentioned, and Dr. Rama Madam has already taken Influminate name during her talk also, that Influminate has already started this kind of journey where PhD theses are, how she digitized the thesis and put. We compliment the MGR Science Institute for coming forward to contribute about 400 medical theses into our repository. So we started as a project. Like anytime when UGC start, they will start as a project. If it is successful, they will establish as an independent body. And we are one of the IUCs, Inter-University Center, which becomes effective from 1996. And if you look at the other IUC's name, NAC is one of the IUC which gives accreditations. Nuclear Science Center, now the name is changed, Inter-University Acceleration Center, IAUC. And this centers and IUCA Pune, DIE facilities, CEC consortium are some of the sister organization like Influminate under UGC, which is having an independent autonomous body status. And we are mainly given the responsibility of digitizing the content as well as sharing the resources available in various universities in the country. And I should say that now we have reached out to about 1,000 plus universities. That is a number. 1,036 is the number right now we are handling, which are having the university status. I'm not telling about the colleges. We have about 4,000 colleges directly taking resources from us. So this is how we started, and we have moved from 96 onwards to 2004 when I joined the institutions. Then UGC Infonet Consortium came and the journal came after that. lot of other projects started, and 2004 onwards, you can till now you can see so many project has been taken. Now Influminate Center is not an IUC of just UGC. Influminate Center is the backbone IT infrastructure for MHRD for many of the projects, including NIRF, Swayam Prabha, UGC website, scholarship portals. So many of the programs, if you are seeing, area, Adal Bihari ranking, anything, and even NPA accreditations, AICTs, some of the projects, all this, everything when it is coming, this is hosted from our platform and handled by our scientists in the background. So NIRF, you must be knowing it, it is National Institutional Framework for Ranking, which ranks Indian universities as well as colleges, which includes all institutions, management, engineering, arts and science, sports, medical, pharmaceuticals. So all this ranking is done by NIRF, and MHRD announces it in every Monday, first Monday of April. But due to lockdown, it has been delayed now. The moment the lockdown is withdrawn, you will see the announcement from ministry. We were happy that in past it has even been announced by Honorable President of India. Now, this is in nutshell about Influminate. Some of the projects which will be useful for your research and innovations, I am going to list out which Influminate is looking after. This first one is like automation. Once the content is created in a university, or if you have enough content, this has to be shared among the university community, academic community. So first we try to find out what is available in universities. So we asked their catalog information, and we asked the metadata of books, we asked the catalog information of the thesis, we asked their catalog information of the video created along with the CEC and the serials. All these universities we club together into a union database. That is what is the first one you see here, INCAT, Indian Catalog, which list out the book, thesis, serial, video, all the databases in this. It is all bibliographical information, not the full text. So INCAT almost sounds similar like World Catalog. There is a World Cat, you can search in Google and find it out. INCAT is the subset version of our Indian version from the universities. And right now we have about 1,41 lakh book records. Out of that, 90 lakhs plus are unique records on that. And we also provide the automation, which I will skip it that because that is something which a library should address to keep track of their publications or their documents and the collections. Then UGC has started a project called UGC InfoNet Digital Library Consortium. Here you can see UGC InfoNet Digital Library Consortium, where in the name of Shodh Sindhu. So Shodh Sindhu gives about 10,000 journal as on date. This is directly available for the universities, depending on the size and also the category of university. There are three categories: core 1, core 2, core 3 universities. So if university is having more student strength, then research is very strong, we give almost all journals, including Elsevier Science. But last year onwards, we have made the university subscribe in some of the content. We have taken very little content from the public money now, because we want to see that universities are really using it when we give it. So that is all about INCAT. And it is a consortia merged together with three components. There was a consortia which provides electronic journal to the AICT institutions like IIMs, engineering colleges, NITs, IIITs, etc. Now that is also been merged with our consortium, UGC InfoNet Consortium, and Enlist, which is a new model 4 years back developed for only colleges, which provide us journal as well as ebooks to them. And this is been clubbed together. All these three model has been clubbed together and given a new name called Shodh Sindhu. So now you can search I will show you some of the screenshot of Shodh Sindhu, where you will get a lot of research content, research article. The other one I should say Shodh Ganga. The Shodh Ganga is a repository of thesis which Madam mentioned already. This is UGC has made a mandatory guideline notification, gazette notification in the year 2009 and amended in the year 2016 to include the plagiarism part of the thesis. And that amendment made and this notification issued and the university started signing MOU with us. The Dr.M.G.R. Institute also has signed the MOU with us and started contributing thesis. I'll show you some of the screenshot of that. Now that is Shodh Ganga and Shodh Gangotri. That is the research in progress. What I have seen during this lockdown period is many people started telling that this research we are conducting. So from 6,000, it has immediately grown to 7,500. There is no mandate for this. So that is the beauty of it. There is no mandate. Still people are contributing who are doing the research. So people who are doing research, they will get an advantage of that. They declare to the world that they are doing the research on this topic. You can upload one-page abstract also, or the approved synopsis, or research in proposal, the proposal you submitted for research in the universities. Then we have the ICSSR data set for social science. I skip it. Then EPG Padashala, Swayam, NIRF. Now all this project, which is very user-friendly in nature as well as useful for the academic community, has listed by MHRD. So I will go to MHRD website to see that what is that. This is Union Catalog. If you are looking for a special book, you can come to Union Catalog and use its search mechanism. The books are 91 lakhs and 1.41 crore records are there. Unique records are 91. So MHRD has given ministry, I think there is a small problem with the slides of this. Government of India, what is the technology enabled learning for researchers? So that is listed here. You can go to this MHRD link. I have technology enabled link. This is a very special COVID special content they created, technology enabled learning. And this is the URL of that. You can put ICT-initiative with the MHRD website and you will see about 13 links which is displayed in that. Some of the links are Swayam, EPG Padashala, Swayam, people might have created content, so that is there. So this e-Shosindhu which I mentioned, which is also given as one of the link there. So which provides about 8,500 journal, 11 bibliograph databases to about 424 member institutions. Member institution means it must be universities, IITs, IIMs, and associated private universities which request for data or subscription. So altogether there are many institutions now logged in, and we are also giving this 6,000 plus journal and 31.35 lakhs electronic books to enlist. So this can be used by research scholars as a research, but this is giving only to the colleges. Maybe medical colleges are not able to connect to enlist right now, even though it is 10 years old, because the policy is only to giving the arts and science college plus some aided colleges. And this is e-Shosindhu. I hope that you are subscribing to some of the content, especially JSTOR, etc. is given to almost all universities. So there are institutions which I circled in the left. I'm not going to explain everything. 3,200 colleges are there and 10,000 journals. As I mentioned, 31.35 lakhs. So these are the member institute, and if you are calling Central University, State University, 12B universities, all these statistics given here. So how the figure of 314 came. And this is what is the list covered in the year last year, and which is continuing even this year also. Gestor, EPW, Oxford University Press, all these are signs. ASME, ACS Journal, ACM Digital Library, AIP, ESS collections. So you can see how many titles are subscribing from each. That is the number of titles given here. ISID database, which is an Indian database given to everybody. All means you, including your university, should get it. Web of Science, annual reviews, project news. So universities, FTIs and colleges are getting the first one. That's why this figure is too high. And second one, Oxford, is only for universities, CFTIs and some selected colleges. AIP is also from, because they pay for it and subsidize. How we are giving? We select universities plus 200 colleges considered as one university and giving these resources. Now, this is analyst component. Since it is not available for you, right now 32,000 colleges are there, and this 4.6 has gone to 8 lakh now users. So this is that analyst web page. Analyst page has changed recently, so you can go and search there. These are the e-journals available from this American Institute of Physics annual reviews under analyst. So these journals can be accessed by the colleges. If a college is near to you, which is an arts science college, they can pay a nominal amount of 5,000 if it is a 12B college plus GST. Or if it is an autonomous non-aided college, then they have to pay about 35,000. Then they can access all these 6,000 plus journals which I mentioned here, plus electronic books. And you can also ask them to have an ID or password. It depends on that policy of the institute if they can do it. But definitely one way or other you will get it. Then these are some of the ebook. You can see library academic collections are almost 1.25, and we have the full collection of Word ebook library. This is also given through NDL. So the money comes from NDL and we are supposed to give it to everybody. So 30 lakhs ebooks you can access through. I hope that you know what is NDL, National Digital Library, which is created by this IIT Kharagpur. Now we also keep track of the statistics of usage so that country justify the spending of money on the research and article is rightly justified against the taxpayers' expectation on the research. So we take this statistic regularly with InfiStat, and I would request you that if MGR Science Institute has not done it, go for the second part, Shibboleth, InFed based. Shibboleth is that single sign-on. Right now we are maintaining many passwords. Google one, Gmail one password, Facebook another password, and all this. If Shibboleth based login is there, many of the application and publishers support Shibboleth. So if it is Shibboleth complaint, you need to maintain only one ID. So even people working at home, they can access these resources through Shibboleth. Many universities has come forward, and I should say that Shibboleth has become a hit during this lockdown. Many universities, at least 50-20 universities immediately started installing, and there are about 550 already using it. And we have JGate Plus for document delivery service. You can request an article if it is very rare, and JGate, by using JGate Plus, wherever the article is available. Look at the figure now, 4 crore 86 lakhs articles. If your article is among this, you can get it through DDS, document delivery service. And there are 26 DDS service center, which is the topmost universities in the country. They are working because they have their own subscription also. So they will be able to provide to more journal. You can see we have only 15,000 journal, but through DDS we are serving to 45,000 journals now. So this is how the model works now. So the InFed is for that. Access can be restricted. Instead of restricting to university, you can have an username, password. Generally, this access is given through accesses are given through IP authentication. But in fact, it is through username and password. And you need to have a technical person. I am sure there are some technical person watching this. They should have LDAP or Microsoft Directory Services enabled for the institution for single sign-on. If you have a username and password used on this platform, you will be able to use it. In fact, So please look out, these are the 46 institutions I have already told you, 46 institutions, and plus another 20 university came forward during this lockdown. So you can see some of the university from Chennai. Alagappa has tested his Avinash Lingam, Bharatidasan, and compliment to the people from Tamil Nadu. We are very exciting to use it immediately. Even I can say that the IRINS, which I will come to across, which when we tested it with the IIT Madras, IIT Chennai. So that is why you can JNU. So all this institute, their faculty member can use the resources from home. So research is not compromised because of not getting resources. So that is what I want to tell if you have. And we are expecting all universities in the country which should be an INFED member. And so this is how people get connected each other. Research is something about collaboration, which she was mentioning, collaboration. So collaboration is possible when people are able to link it each other, when you are getting resources each other. Now INFED plus IRINS will change the way the Indian research is going on. I repeat the statement, INFED plus IRINS, Indian Research Information Network System. These two together will change. IRINS will give the complete research profile of all the researchers in the country in a single platform. Even ministry has given about 1.5 crore rupees to give access of this INFED, access of this for IRINS, to give connection of IRINS to about all centrally funded institutions. That means already ministry has taken care of the institution which they are funding, and we are providing this IRINS. Now similarly, private universities come forward, and they also, Madurai Kamaraj asked a mail, then we told we can test it, and they have done it. So I request you that if you have not done it, try to install it in for your university. It will be useful. And I told for documented delivery service. And I'll tell you there's one word called search is known to everybody because you are all using Google search. But federated search, which is single search on a portal where you get from various sources. Search is available in every publisher website. Search is available in InfluMnet website. Search is available through search engines, Google, Bing, or whatever. But federated search give you the search among the most popular journal which is subscribed by Indian universities. So JGate Plus has developed with a view of major journals subscribed by Indian universities, which you can see PubMed and all the other Elsevier, Science, Springer, Taylor and Francis. All these journals are part of JGate Plus. So that's all about the resources which is getting available from InfluMnet Center. Now I'll just quickly go to the first link which is available in MHRD website. Swayam, you must be knowing that it's Swayam MOOC is a platform where you can offer courses. And I was one of the course coordinator of a topic called research ethics. And from MGR Institute, Dr. Rema Madam was one of the faculty member who contributed to for the research design thinking process. That was the module. This module is still available, and about 3,000 people, 2,900 exactly, has enrolled for the course. And those who wanted certificate, it's a 4-credit certificate which can be transferred from one university to other. So UGC has given guideline to universities. You don't need to do your course if it is available online in a university. You don't need to do that course in your university. That is what I mean. You can opt for that same credit course from other university, attend all the classes, also attend the test, and you get your credit is transferred from the host university to your university, and that will be reflected on your certificate. So 30% of this course you can do it online. That is what now it has been increased, but I am not very sure whether 100% course still you can do it, but there are possibilities that you can enroll the course from various and make it syllabus based on university, and the university should give you certificate if you complete it. So right now Swayam has come up with a lot of, you can see the last verse, let the COVID-19 not stop your learning, continue with SWAYAM. So SWAYAM has so many hits in this lockdown period, and there is a course catalog, you can search on that, and I have not done any analysis of medical related topics in this platform, but I am sure biotechnology topic is there, microbiology topic is there. So they are all delivered from the best faculty, and you can imagine that even I have used one module out of 30 module, Dr. Rama. I have my faculty include from JNU, from the former director of InfilmNet, from Osmania University, Goa University, Gujarat University, and these are the faculty pool we used for creation of one SWAYAM module content. So you can imagine that how best the people are using. Many universities started offering courses on SWAYAM, and SWAYAM is the Indian name of MOOC, and we call it as SWAYAM MOOC. MOOC is Massive Open Online Courses. So these are the courses. You go, this link is given there. What you can do that this link you can cut and paste it on your desktop and see it later. And so, excuse me, nothing to worry about it, but I have developed a small cough because of the cold water. Now SWAYAM online course, you can see the first, the other one is ICT initiative of in SWAYAM. So some of the very interesting things are given here, and another project which is almost SWAYAM, it is SWAYAM, the spelling, please take care of the spelling, it is SWAYAM Prabha, spelling SWA SWAYAM Prabha, and this was launched in 2017. SWAYAM Prabha has 32 education channel. Those people who are visiting our web, who are listening to this, I don't know how many of you know that there are 32 free education channel coming to your box, set-top box, and every channel is supposed to give it free of cost to you. If your channel is not providing, you can contact them. And every day there is a program, and SWAYAM Prabha, this platform is maintained by us. We have the catalog information, which program is, which channel is going to get. So keep it in your browser and do it. And can I take a feedback on this time? Meanwhile, can I take a feedback from anybody who is listening?
Yeah, you're going good, sir.
Yeah, thank you very much, and I'm going. So if it is visible, you are only watching my slides, no?
Yes, we are looking at your slides. It's very clear, and your quality.
Sir, your voice as well as PPT both are clear, sir. Please go ahead.
Sir.
At present,
yeah, thank you.
Persons
and
are
how
watching.
many minutes? How many minutes remaining now for me?
Please finish at 2:45, sir.
10 minutes.
10 more minutes.
Yes,
yeah, that's absolutely
last
fine.
2 minutes you dedicate for question and answer, sir. Please.
Question and answer, definitely.
So
that has given a break for the participant as well as for me, your interaction. Thank you very much. Again, I'm Manoj Kumar coming back on this topic again, research and innovation provided by Dr.M.G.R. Institute. So this is what is available in MHRD website. We have been circulating to everybody. NDLI, National Digital Library of India. You have so much content available, including the content created by us, Shodh Ganga. We are giving our metadata content to NDL. We are giving a book database content to NDL. So if you are searching there, they will redirect. When you click on the link, it directly comes to us. So NDL is supposed to serve as a national digital library of all information. And I do request that there are new courses content announced during this time, and as a freebies, if you look at to the publishers, Springer is a costly priced publisher, and Springer has given about more than 100 book free of cost now. You can download.
Yeah, I'm able to.
This is during lockdown special. This is lockdown special. So many of the publishers, they have come across with the free content. In addition that, I mentioned about SWAYAM MOOC. SWAYAM, the MOOC, there are international MOOC platform like Coursera, edX, Udemy. These are three popular. And some of the people, they have announced it free of cost now. You don't need to pay because of it is COVID lockdown. So MOOC otherwise sometimes it is called open and free, but this platform charges $25, $50, $30, $90 like that, because they issue a certificate also, and there are interactive sessions. But COVID special, many of them has made it free. This is the best opportunity you can do. Even TCS in India has made some of the advanced Excel and all that. And even my son studying at 10th standard has finished the advanced Excel sheet now, Excel course now on this MOOC. And artificial learning and big data analysis and machine learning. Ladies and gentlemen, I just tell you that these topics are not technical. The way you listen to that, AI, big data analytics, and this AI. And somebody mentioned that if it is next 10 years or next decade or next 20 years, what is going to be the most attractive subject which we should work on? And somebody gave the statement, the most sexiest topic in academic field now is AI, machine learning, as well as this data, big data analytics. Because any data, madam was showing a slide of COVID integrated from many people, showing it, how this was happening. This is nothing but data analysis with an AI tool working in the behind. So that is what we are like right now. And India also, many of the applications government is using, the background it is there. So data analytics is one of the very, very important job. Anybody can do it, even a medical profession, unless you get that right job and analysis is done. COVID, what is required in the background is the thorough analysis of data, where from it is spreading and what age group it is spreading, who is the nearest spreader, who become the super spreader, or which category of people are more vulnerable to get this kind of disease. This cannot be done by survey or this, except there should be a collaborative network, research, input, as well as data in the behind to analysis. So NDL give the resource content of many of the things we are looking for. And E-Yatra is for engineering, and I skip it because I don't think you have many engineering students, but biotechnology, etc. I request you come here, watch our video, upcoming workshop, and this is for students, colleges and teachers. So you can enroll as a college, and whatever is beneficial coming in E-Yantra, give it to your students as a kind of message or social media tagging, hashtag, etc. And this is virtual lab project. It's also taken from Ministry of HRD. These all 13 links are given in MHRD website right now. This is being created during this lockdown because education should not stop in India at any cost. That is the fundamental idea. Movement is stopped, but education and research should continue. And there are spoken tutorial available on that, an open source based spoken tutorial platform called vlab.cov.in. So they also asked for the nomination of awards, reimagining education, re-engineering, how the new arena can address the educational needs of people. And this is FOSE, free and open source software project. And there are so many projects available here. You can join if you are interested. FOSE.in is again an initiative of government. So you will see that the COVID declaration and notifications are appearing in all the projects time to time. This is the FOSE.in. And have you heard about something called open drug discovery? And hopefully that is one thing which you can focus. There are a lot of open drug discovery, which is not substantiated by the pharmaceutical companies which are looking for profit. But there is a model, humanitarian model, where open discovery, and this IISc has a special lab on that. They have so many collaborators. They look for volunteers who are interested to coordinate, and you can also join on that. And now coming back to the project which I handle, Shodh Ganga, which is also listed there, I am very happy to tell you that as on date, the highest page views among all the MHRD projects is Shodh Ganga. Starting from 24th March till today, yesterday evening, 8th, we have 92 lakh people viewed content from Shodh Ganga. We have an average of 8,000 users visiting Shodh Ganga every day for research. So this is a remarkable achievement as far as Shodh Ganga is concerned, and it has never failed in this. Generally, people tell that it is a little slow, sometimes it is not getting, but we have seen during lockdown, this has never ever shut down, or we have not even rebooted the system even for a minute. So that is the advantage of Shodh Ganga. And Shodh Ganga, another sub project is called Shodh Gangotri. I have already addressed almost maybe many of you on this topic, so I will just skip it. So we have Shodh Ganga, OJS for subscribing and journals, Infoport, ICSSR dataset. These are all on open access model. You don't need to log into system. You don't need to register into this portal. You just come and use it as how you are using Google. Just give your keyword searches and download, and absolutely no fee, no registration required. You are free to read, browse, download, whatever things you want to do with these are all high reviewed research thesis content. You know, thesis is awarded only after a thorough review on that. So Shodh Ganga has, as on date, it has 2,70,000 about PhD full text theses available, and I have seen about 10,000 plus medical related theses on this, and it could be more if one of you work on that, and we need some people like you to work on Shodh Ganga on the medical thesis, which will be very useful, and we can give it as a special link. So InfluMNet is not just an institution working alone. We are working with collaboration with many people for our content creation. So we are looking forward for the medical community to work on that. The last few years, and if you look at April, Shodh Gangotri has gone with the 500 PhD synopsis. March 59 this, and we are very happy. This is because of the lockdown. People started uploading. They get time now. They are giving it, and this is how yearly wise. First few years, 3 years, Shodh Ganga has hardly 10,000 theses, but last 4-5 years, 2015 onwards, if you look at, it has jumped from 28,000 from 14 to 6 years. Today 2.69 lakhs. Exactly, if I take it, it is 2,69,850. So if I add 150 theses, it is going to be 2.75. So this is the URL. You can go to Shodh Ganga, and this is the exact figure which I mentioned. So if you look at in 1 year, how many? So in January 2020, we have only 2.5. So another 20,000 theses, 70 means 20,000 theses added till May 9th. And we are feeling a little bit slow now in the second lockdown, which is announced after 14. People are not uploading, means universities are completely locked down. Even InfluMNet Center, we are on complete lockdown. Nobody goes to our office now. And that is as per rule, we cannot.
Manoj sir,
Yes,
sorry for the interruption. Yes.
Yes.
Please finish it, sir. We are running short of time. Yes, sir. Yes.
Yeah, I'm finishing it. Shodh Gangotri, yes. And this is what is Shodh Ganga. I will finish it in 2 minutes.
Yes, sir. Please.
Okay then. Shodh Ganga, and which are the subjects available PhD, and these are the PhD theses I'm talking. So whenever you are conducting a research, first come to Shodh Ganga and see that how many theses. We have done a subject-wise analysis, which is the figure here, and these are the language-wise theses available. The picture shows, and I skip it. And this is during lockdown time how before lockdown how Shodh Ganga was responding, but after lockdown, during lockdown, you can see that average number of visitors more than 2 lakh. And I'll just skip it because you told. And we have an anti-plagiarism software provided to your university as well. That is called Urkun. It is under the name called Shodh Shuddhi. And right now, 1,032 universities are using. 78 faculties are registered on that. If anybody is there to get registered, it is free. You can use this tool free of cost. You contact the madam there. She is the coordinator. And this is Vidwan. database, which I skip it, expert database. This is one thing I want to tell you. With this, I will stop it. IRINS, Indian Research Information Network System. So all universities' research should be linked together. Indian Research Information Network System, IRINS. And you will get the details of 30,000 faculty right now. They have about 6,12,000 publications with a citation, remarkable citation of 8 crore, 80 lakhs citations. So when you are part of IRNS, you will be also linked in the network. So IRNS is going to change Indian research, which I mentioned earlier, and this EPG Padashala will give you content of various 70,000 contents, which is available UGC MOOCs. For people who want to just have a idea, I'm just NPTEL programs on enhanced learning, or National School of Open, e-Padashala, and there is a special COVID special there. Diksha, it's for knowledge network people, National Education Alliance, NEET. These are all new projects. ICT free courses, free.iict-India. So some of the free courses you can attend. eGyan Ghosh, National Digital Repository. And I think with that, I will like to stop the sharing of the video, and you must be having some question, and I will come online for a minute and I'll take question. That's all. Thank you very much for inviting me for this session to give the contents on research and innovations. I have given justification on research. Innovation is something which I have to work with new startup companies, which has to be updated, which will take some more time. If anybody is doing that, that is more what is the innovation happening in the country. But next time, if possible.
Thank you very much for this excellent talk. I have just one question.
Yeah,
you would so the Shodh-Ganga PhD theses are getting cited in I think publications and other theses also. Is there some metrics which tell us how many of them are getting cited? So just like we have the citation index, can I find out for publications, is there a citation index for PhD theses?
Madam, right now we have made Ultrametrics. Is for social media interaction. How many people share it? How many people use it in social media, Facebook and WhatsApp sharing? That count Ultrametric is already doing. The other one, which you asked about the citation, if you go to the Google Scholar, scholar.google.com,
okay,
you give the thesis content number, it will show you how many people cited it.
Okay.
That is what is available. But I don't know whether Web of Science and Scopus started giving the citations of thesis there, but Scholar will definitely give you. I have seen 150 citations for one of the theses by using Google Scholar. We have a tie-up with Scholar for that.
Okay, thank you, sir. So, Mani sir, do we have time for a few questions from the audience? We have collected some questions. So maybe one of them, some of them if you not, yeah. So one question is the Vidyamitra open source initiative?
No, Vidyamitra is not open source. Vidyamitra is a platform for all the projects conducted under ministry.
Okay, I see.
There are so many video content created by people like NPTEL, IITs, all. So ministry, whoever ministry funded, they wanted all this together on a portal. That is what is Vidyamitra. Okay. And you will see 40,000 videos there in Vidyamitra. Right, if you look at in EPG Padashala postgraduate base, it is about 20,000 plus. So that means all the video of CC, everything which is valuable is been indexed in Vidyamitra. It's not an open source. Whatever I mentioned here today, none of them are open source, but some of us use open source platform to launch it.
Okay.
Like Shodh-Ganga also use open source. That is called DSpace. And other open source products are listed in FOSE.
I see.
Okay.
Okay. So just one more question. So there is one person who wants to know how to join institutional repository of InflibNet. So the answer I think is it's mandatory for all colleges and institutes to be a member of InflibNet, isn't it, sir?
So, madam, joining is it's a vague word. Joining. What is joining means? InflibNet provide resources. In universities, we directly provide to them, so they don't need to join. The university which are all 12B courses, but the university which are by AICT etc. that some of them AICT list that also we join. But colleges, they can join enlist program. So there I can use the call joining. So they can join because they have to subscribe the content. So that's why they have to. So joining is only for enlist. The rest of 80% of our content is free. They don't need to join. But by joining means colleges should promote the content among their faculty to use it, like Shodh Ganga. That can be done. But otherwise they don't need to join. Only university join, they upload, people use it. That is how the model works.
Okay. Thank you very much, sir, for the time that you have spent, and it's been extremely useful. And we can see the enormous effort put in by the UGC and InflibNet and ensuring information is available to researchers. Thank you again, sir.
Thank you very much. Thank you.
So will you introduce him and we'll start the... So Ganesh, who will be going on live to introduce Dr.
Next chief guest is available.
Yes. So Mani sir, you start and then we'll have the video and then Ashok sir can start.
Ladies and gentlemen, I'm very happy to introduce our speaker, Dr. Ashok Rao, Associate Director, Research and Consultancy, and a Professor in the Department of Physics, Manipal Institute of Technology. Dr. finished his BSc in 1986 from St. Stephen's College, Delhi University. He then completed his MSc in 1988 from Delhi University in Solid State Physics, and he completed his doctorate in 1994 from Delhi University in high temperature superconductivity. He started his career in the year 1997 in SMIT Sikkim. Then he became a head in the Department of Physics and he worked there till year 2007. In 2007, he joined as a professor in MIT in the Department of Physics, and he is presently working as an associate director in research and consultancy. Some of his areas of interest is high temperature superconductors, magnetic materials, and thermoelectric. His research experience, research papers in index journals is 100, number of PhD students guided is 7, number of PhD students at present is 5, number of postdoctorate student is 1, sponsored research projects is Rs 25 lakhs from BRNS completed in March 2015, Rs 23 lakhs from CSIR which is ongoing, Rs 134 lakh coordinator FIST from DST. Some of his membership in the professional bodies: he is a life member of Indian Science Congress Association, a life member of Semiconductor Society of India, he is a life member of Indian Physical Society Kolkata, and a former member of IEEE. He has a H index of 14, total citations of 776, and total number of publications as 107. On behalf of Dr. MGR Educational and Research Institute, we thank him and wish him good luck for his future endeavors. Thank you.
Yes, sir. Please. Please share your screen, sir.
Yeah, I'm doing that. Can the screen be seen?
Sorry, sir. Screen is not visible.
1 second.
Now your screen is visible, sir. Share PPT.
Yeah. Is the
Yes, sir.
screen?
Now your PPT is visible. Please go ahead, sir. Please.
Okay. I am also visible.
Yes, sir. You are also visible, of course.
Okay. So I can start now?
Yes, sir. Please start, sir.
Okay. Good afternoon, ladies and gentlemen. I would like to thank the organizers of One Day Faculty Development Program, and in particular, I would like to thank Professor Manivannan for giving me this good opportunity to be a speaker in this FDP. Now, before I start my talk on resources for research funding, it is important that in science, engineering, and other related fields, knowledge is dynamic and it changes very rapidly. Now, what a teacher learned 25 years back becomes obsolete and a teacher has to update. For instance, in fields like computer science, electronics, and related fields, the technology changes very fast, and it so happens that the technology can change after 5 years. So it becomes utmost important for anyone to update the knowledge. Now, let me say what is the meaning of research. Research is basically the process of creating new knowledge, and if you have to create new knowledge, then you must have significant amount of background knowledge. So to know background knowledge, what we have to do is teaching, or what we do every day is nothing but what we learn in the background knowledge. But in order to understand research, we must get involved in the new findings, and hence it is extremely important for anyone to do research. Now, next question is, why do institutions of higher learning or higher education demand research from faculty? Now, you see, education is no longer localized. It has in fact become all over India, and more than that, it has become global. And if you see, most of the institutes like ours and MGR Institute and so on, all are interested in talking about what is called ranking of institutions. Now, ranking of the institutions is on the basis of different ranking schemes like QS ranking, Times ranking, and so on. So ranking becomes very important if you want to have a global recognition. Now, if you see carefully, the institutes which are extremely good as far as ranking is concerned for undergraduate education are also extremely good in highest ranking in research. So thus, we can say that teaching and research go hand in hand. Now, the next question is, why do we need funding? Somebody may say that, okay, you have the aptitude, you have the attitude, you can do research. But the answer is, you know, that all those who are in science and engineering, we require huge amount of money. Now, that kind of a money, neither the government can give nor private management can provide that quantum of funds to undertake research in particular, or otherwise we can say extremely high-end research for faculty members is extremely difficult unless we do have some kind of funding. Now, this is also the driving force behind the funding agencies. that they give funds, because each university or institute cannot have that kind of funding, and hence the government has to have some kind of funding agencies. And not only government, now this concept is coming in India also, the private industries are also giving some kind of fundings. Now, if you talk about the fundings that which are there, the government of India normally funds both basic as well as applied research. Private industries in India normally support applied research beneficial for the society, and that is expected also because that is what the private industries are looking for. However, in many of the developed countries, many of the industries are also giving money for fundamental research. Now, whether they give money or not, what is very important is what is the way or what are the various funding agencies where we can look for. So, starting my talk, I would say that my talk will primarily cover grants which are either individual grants or the grants which are institutional grants. And then I will also be talking what are the various funding agencies that you can look in. For example, DST, AICTE, CSIR, DAE, INSTA, DBT, and ICSSR. Then next part of my talk would be regarding the grants that you can see for organizing seminars, conferences, or even travel grants. Now, why these grants are important is that these grants give rise to networking. And you know that networking becomes very important if you want to have collaboration within India or you are looking for collaborations out of India. Now let us come to the first area, which are the individual grants or any faculty member who can give or who can apply for these grants. So I will start with the Department of Science and Technology, and the basic aim for having the Department of Science and Technology is that primarily the audience is from science, technology and management, and I thought that I will start with the Department of Science and Technology. Now, science and technology basically gives four kind of individual R&D projects, and they are part of what is called Science and Engineering Research Board, which is called SERB. And the four primary core branches that they give is the core research grant, then there is a startup research grant for young scientists, then there is another scheme which is funding industry relevant R&D, and then there are some special schemes for which everyone may not be eligible, but there are some particular schemes which will be there. Now I will start with the core research grant scheme. Now in this talk I am going to give all the research schemes which are possible, and I am also giving the relevant websites, and this PPT will be with the organizers, and I am sure that if you request they will give you the slides and you can see what are the various websites. Now the core research grant scheme is basically a scheme which is provided for supporting active researchers to undertake research and development in frontier areas of science and engineering. The funding is basically provided for a period of 3 years. The research grant is provided for equipments, manpower, consumables, travel and contingency. And of course, there is something which is called overheads, which is also given to the implementing institution. And depending on the institution, sometimes these overheads can also be used for certain kind of expenditures if the institutions allow. The main thing that we should know, what are the eligibilities as far as the core research grant is concerned. The applicant must hold a regular academic research position in a recognized academic institution, or it can be even a national level laboratory, or it can be a recognized R&D institution, or it can be even a private academic institution, but of course they should be either UGC recognized or AICTE recognized. And it is important to know that the PI and the co-PI should hold PhD degree in science, mathematics or engineering, and if they are from medical side, then they can be MD, MS or dental, MDS or in veterinary science. at the time when they are applying for the grant. So next I will come to what is called the startup research grant. So obviously this startup research grant is something which is applicable for comparatively fresh people, and the scheme aims to assist researchers to initiate their research career in a new institute, and it enables researchers working in fronting area of science and engineering to establish themselves and maybe to move on to the mainstream core research grant. And of course, these grants cover all the usual things like equipment, manpower, and so on. And the qualifications are same as I had mentioned in the earlier scheme, which is a core scheme. Then I go on to the next extremely important scheme, which is the scheme for funding industry relevant R&D. Now, before I talk about this, it is extremely important that whatever research we do in applied science or engineering, the end product has to be very, very beneficial for the society. And as I told in the beginning, unless there is a product which comes out of research, the industry will not be interested in putting in any money. So the objective of this scheme is to basically utilize the expertise in academic institutions to solve industry specific problems for larger benefit of society. Now here there are two kind of partners that we will be talking about. One is the academic partner. So the academic partner should hold a regular academic or research position in an academic institution, or it can be even a national laboratory. And the industry partner can be all kind of industries, or they can be even industrial R&D centers. And it is possible that one can have more than one industry, or one can have more than an investigator as far as this project is concerned. In fact, in any applied science or engineering projects, it is extremely important that it is a teamwork, and unless we have more than one person working in this field, the project becomes very difficult. And then the important part is that the proposal should be jointly designed and implemented by both the academic partner and the industry. And of course, there should be a relevance as far as the project is concerned to the industry. It should have an innovative approach to solve the problems. It should bring in some kind of innovations, and it should aid technology transfer and commercialization. Then, of course, as I told in the earlier schemes, the overhead is given only to the academic partner, and even the support from SCRB is given only to the academic partner, and the industries are supposed to pull in money so that they get benefit from the academics. Then, as I told, there are some schemes which are special schemes, and the scheme is called Empowerment and Equity Opportunities for Excellence in Science. And it is aimed to support the researchers basically belonging to scheduled caste and scheduled tribe in undertaking research areas in science and technology. Of course, they have to be in any of these categories, and of course, they should be PhD in science and engineering, or they could be from the medical field. Then extremely important is the Women Scientist scheme. Now, women are extremely important part of the research in any institute, and to encourage women, there is a special scheme and a special opportunities provided to women and women scientists and technologists. And many a times, some women have to take a break in their career and they want to again get into the mainstream. So there are basically three types of schemes which we have. They are the Women Scientist Scheme A, which is for research in basic and applied sciences, and then there is a Women Scientist Scheme B, which is in science and technology interventions for societal benefits, and there is yet another scheme called Women Scientist Scheme C, which is internship in individual intellectual property right for self-employment. Now, coming back to an extremely important organization which controls all the engineering colleges, and I understand that many of the participants are from AICT. So AICT recognized colleges. So AICT has some schemes which are for individuals, and they are the research promotion scheme, and another important aspect in any technical education is the entrepreneurship development cell. So these are the two important schemes for which they are giving funding. The research promotion scheme is basically specific to the areas of technical education, including science, and this scheme is aimed to create research ambience in the institutions by promoting research in engineering sciences and innovations in established colleges as well as newer technologies. Now, this scheme also has a benefit that the scheme has the aim to generate masters and doctoral students to augment the quality of research. So what it means is that the AICTE wants that there should be some masters or doctoral students who should be attached to this kind of a project wherein they can work for the project, and while doing that they can also get their degree. Then there is yet another scheme by AICTE which is called the Entrepreneurship Development Cell, and this is basically to create an environment for self-employment and entrepreneurship development through formal and non-formal programs, and to introduce the concept of entrepreneurship in curricular degree and so on, and to utilize the infrastructure facilities which are already available, and to train manpower for the development of non-corporate and unorganized sectors. And this also promotes a kind of employment opportunities for technical people as well as for people who are skilled. Then I will come to another important granting agency which is called the Council of Science and Industrial Research, CSIR, which provides financial assistance in the fields of science and technology. The research proposals of usually applied nature are falling into these schemes, and it is also important that if it is possible for the researcher to involve one of the CSIR labs, and if it is of multidisciplinary nature, then priority is given for these kind of projects. Then coming to another key and important area is the area of atomic energy, and the scheme which is given by Department of Atomic Energy or DAE. So Department of Atomic Energy supports research and development activities in nuclear and allied cells, engineering sciences and technology, and for this they have a nodal agency which is called the Board of Research in Nuclear Sciences, or it is abbreviated as BRNS. Now, the broad area of support include physics, chemistry, biological sciences, and almost all areas of engineering like mechanical engineering, civil engineering, electronics and communication, you name it, all the areas are needed for these kind of schemes. However, there are some conditions and restrictions as far as the atomic energy projects are concerned. I'll come to that in a moment. Now, there are basically three types of projects which are given by these, and the first one is the regular research project, the next is the Young Scientist Research Award, and the DAE Scientific Research Council Award. Even this award is also a project, although it may look that it is kind of an award. The regular research project is basically for providing high quality research and development or advanced concepts which are of relevance to DAE, and the people who can apply should of course be working in universities or academic or research institutions, and of course they should have a regular position. But the projects which are provided by DAE are very specific, and the specific is basically towards the relevance to DAE. So in this regard, we should have a PI who should be from a university, and then one should also have a principal coordinator or called PC from any one of the Department of Energy institutions, and a co-investigator from the same institute where the faculty is working is also important as far as application of these projects are concerned. The next is the Young Scientist Research Award. The main objective of this research is to encourage young scientists in the initial years of setting down their career, and they are provided with necessary grants of setting up their laboratories. And this is also an extremely important grant that it is aimed at the NRI scientists, and basically it is luring them so that they come back to India and they contribute to our motherland. And this scheme is, as the name suggests, it is Young Scientist Research Award. So it is only to the scientists who are below the age of 35. And unlike the scheme that I mentioned earlier, it does not require any PC or CI as far as this grant is concerned. Then there is one more prestigious award, which is basically a research grant called the DAE Scientific Research Council Award. And this award includes a grant up to 1 crore spread over a period of 5 years, which shall be used for sole purpose of pursuing research project which is submitted. And not only that, in this particular award, why it is called award is that a faculty can get up to 25,000 rupees per month as an additional amount to the salary that they are usually drawing from the employer. But of course, suppose there are some employees which are giving some performance relative incentive schemes, then both the things cannot be given. The employer has to give only one of them. Now, I'm not very sure how many of the participants are from biotechnology field, and I'm also not a very expert in the area of biotechnology, but I can tell you that there are several areas of funding given by Department of Biotechnology, Government of India, and the broad areas are medical biology, agriculture, animal and allied sciences, energy, environment and biosources, and programs for societal development. Then I thought that we are having a lot of schemes for people who are from science, technology and so on. Then how about for people from social science background? So there is a specific organization called Indian Council of Social Science Research, and this gives research schemes for a lot of domains belonging to social sciences. For example, sociology and social anthropology, political science, public administration, economics, international studies, social geography, commerce, social psychology, education, and so on. So for more details, you can see the website which I have cited in the slide. Then, just to briefly tell you what are the schemes that they have basically two types of schemes. One is what is called the major project, which is up to 2 years, and the budget is about 5 to 15 lakh. And the other is what is called a minor project, and duration of this can be up to 1 year, and there is a limit as far as the project is concerned. It funds only up to 5 lakh. Then I will come to another major research organization, in fact UGC, and it is UGC which is giving salaries to most of the central and the institutes which are in different states. But here I would like to emphasize on 2 or 3 different things. First, UGC promotes social science, language, literature, pure science, engineering, pharmacy, medical, agriculture, you name it, they are giving to all the fields. And the emphasis is to support such areas that cut across disciplines, and the subjects include health, environment, biotechnology, and nanotechnology. However, there is a catch in this, that the University Grants Commission provides support only to permanent faculties in the universities and colleges which are under Section 2F and 12B of UGC Act only. So that means that it would normally be given to government or state government universities. However, some of the self-financing institutions can also fulfill certain conditions, then they can get grants of this type. In fact, the permanent teachers working in self-financing institutions which are stipulated due to some kind of fitness of institution for Grants Rule 1975 and subject to the condition that the fees that is charged by such colleges are in accordance with the state or university fees regulations or laid down by any law as time permits. Now I will come to the last leg of the individual projects, and as I told you that Department of Atomic Energy provides funding to almost all the institutions, whereas UGC provides funding to basically the central and the state universities. However, a collaboration of the two or a combination of the two is what is called the UGC DAE Consortium for Scientific Research. Now, the purpose of this DAE Consortium for Scientific Research is that every institute cannot have high-end instruments. So, keeping this in mind, the Government of India thought about starting 3 centers to begin with, and they were in Indore, Mumbai and Kolkata. And then of late they have started a center in Kalpakkam. So the aim of this consortium is to have facilities which are general facilities which can be utilized by any university faculty. However, these fundings are limited to JRF and contingency and travel grant. But here any JRF or even the faculty can visit these consortia, and every time they provide the travel as well as accommodation. So these 3 or 4 institutes are extremely important as far as small projects in which one is interested in having a JRF and a small contingency. So in that respect, these 4 institutes are extremely important. Now I will come to the second leg, which is called the institutional or the departmental schemes, and I will start again with the Department of Science and Technology. So there are basically 4 kind of schemes which are available for funding. One is the Fund for Improvement of Science and Technology Infrastructure in Universities and other higher education institutions. It is called FIST. Then there is a very important scheme which is called Sophisticated Analytical Instrument Facility, or SAFE. Now under this SAFE scheme, one can apply for projects even up to 50 to 100 crores, and one can procure high-end sophisticated analytical instruments, and the scheme of this is basically to cater to the needs of nearby institutes as well as our own institute. Then there is one more scheme which is called Promotion of University Research and Scientific Excellence, which is called the PERS scheme. And there is another scheme called Sophisticated Analytical and Technical Help Institutes called SATI, and the details are given in the website. And I would like to tell you that the SAFE and PERS can be applied anytime, but as far as the FIST is concerned, there is a specific timeline, and every year once they do that. And unfortunately, this year in first week of May, the last date is over. Then AICT also gives some amount of money for modernization and removal of some obsolete lab, which is called MODROP, and under this it equips technical institutions with laboratories and some small computing facilities which can basically enhance teaching as well as research capabilities. It supports development of lab instructional manuals also, so that the practical work which is carried by students is contemporary and suited to the needs of the industry. And this scheme is for all kind of institutions, whether they are in big cities or they are in small or rural areas. However, only for rural areas and northeastern region and Jammu and Kashmir, there is a special scheme for modernization and removal of obsolescence for rural area. So in this scheme, only institutions which are technical institutions stationed in rural areas or northeastern region, they can apply. So this finishes the funding part, and now I'll go to the end of my talk, and I will be having basically 2 types of things that I would like to mention. One is the grants for organizing conferences or workshops, and the other is the travel grants for presenting papers in conferences. So almost all the funding agencies give travel grants like DST, AICTE, CSIR, UGC, INSA. So the travel grants are again of different types. For example, CSIR gives full travel grants for young scientists less than 35 years of age, and those who are more than 35 years of age, they have partial travel grant. Then DBT gives travel grants for people working in biology or medical field. Then Department of Science and Technology gives grants for international travel support, and again for young people it gives 100% travel grant, and those who have more than 35 years, usually they give partial travel grant. And even AICT is giving travel grants to faculty who are working in AICT recognized institutions. So they are also given travel grant in various schemes they have. But of course, one should know that there is a time limit which exists for all these travel grants to apply. So typically 3 to 6 months. So that means before you intend to go for any conference, you must apply for these grants at least 3 to 6 months, so that these funding agencies will have sufficient time and they can go through the applications. So with this, I come to the end of my talk, and I would like to know about the question answer session.
Email you some questions, sir.
Yeah, I will do that. So should I start?
Yes, sir.
Okay. Yeah. So now I will take some of the questions, because as the audience is very big, so it will not be possible to cover many questions, but I will try to cover as many questions which have been asked by the audience. So I have taken about 8 or 9 questions which I would be answering. So the first question that is commonly asked by many people is, what will be the future challenges for collaborations in research and innovation basically after COVID? Now let me tell you that this FDP which was organized is also an offshoot of one of the challenges of COVID, and this is a platform where so many thousands of people have participated and are participating, and they are listening to many talks. So I would say that this is a challenge that we have to do. Now, as far as the answer to this question is that yes, the biggest challenge will be economic lockdown, which will certainly reduce government and industrial funding. But I feel that this will bring various international communities together to work, and I feel that this may give rise to the concept of sharing knowledge and facilities, which I feel would be a blessing in disguise. And I understand that due to this slowdown, the research activities may slow down, but I am extremely sure that the world will work and overcome this, and we will be back to pre-COVID area. Then there is another question that some people have asked is, how to get funding for projects from government or international agencies. Now basically this question is pertaining to international agencies. So what I would suggest is that a funding agency like Department of Science and Technology, they have a special scheme for international collaboration, and these international collaborations are usually aimed at a particular country. Say for example, it will be called Indo-US funding or Indo-UK funding or Indo-Canada funding. So time to time there would be advertisement, and you can always log on and see what kind of fundings people are asking, and one can apply. But very important thing is that you should have a collaborator as far as the other countries collaboration that you want to do. There should be a faculty known to you, and both of you will have to write the project together, and the international counterpart has to submit in their Department of Science and Technology or whatever they call, and the Indian counterpart should submit to the DST of India. Now there was one more question that people have asked is, again it is post-COVID, so they are asking is, which area or which areas are likely to get attraction more and more in innovation after COVID-19. Now, if you really see, the first very important thing is the health sector, and primarily including the pharmacy. So I would say that first thing which would be very important is testing. So testing of all these kind of pandemic that we have, so that would be one area where a lot of work people are doing, and this will be one of the challenges in the healthcare organization. Then as I told, pharma companies would be another where people will be doing a lot of work, and there would be a lot of money available for research and innovation. Now there is yet another thing that we are, all of us are observing, is called social distancing. Now, in fact, we are following the social distancing. I am sitting in Manipal and the organizers are in Madras, and the people who are participating in this are from different parts of India. Now, because of this, what will happen is that not many people will go to shops or big malls to buy things. So I think one of the areas which will be a renaissance would be e-commerce. So that means that a lot of computer science and engineering or electronics and communication engineers will be required to do work on the software related things and other key areas as far as the e-commerce is concerned. And another area which I feel would be of importance will be the artificial intelligence, then virtual reality and so on, because this would also be important for, say, media and entertainment industry, where at least for some time we will not be able to enjoy the media. So this is one more thing that would be of interest. And the last speaker has already talked something about software to check plagiarism. So the question asked was, which is the best paid software to check plagiarism? So I would say that there are several softwares which are available, but primarily I would say the Authenticate and Turnitin are the two important softwares which are often used by the journals as well as institutions. But I would say that Turnitin is a much cheaper software, and that is how it is mainly used in educational institutions, but most of the journals use Authenticate as far as this software is concerned. Then there was a query by many of the people who are from psychology, and in fact let me tell you that honestly I am also not from psychology background, but I have gathered some information by which I can clear some of your doubts. So the question asked was, how can we collaborate psychology with departments for research, that is with other departments for research? So the answer to this is that those who are from engineering background, they know that you do study some kind of psychology, and it is called engineering psychology, or you also call it human factors engineering, and it is the science of human behavior and capability applied to the design and operations of systems and technology. As an applied area of psychology, it aims to improve the relationship between people and machines by redesigning equipments, interactions, or the environment in which they take place. Of course, medical psychology and environmental psychology are very important interdisciplinary areas where psychology people can do work. Then business psychology is yet another area where a psychology person can always interact with business community. Of course, there are a lot of discussions today regarding research and innovation, and a lot of people have covered as far as research and innovation is concerned. So what I would say is that research is nothing but giving new knowledge, and innovation is that you take this knowledge and develop a useful product. So I will say that developing a useful product would be an innovation, and giving a new knowledge would be what is called the research. Just to give you a very simple example, I would say that if you are teaching thermodynamics, it is research, and if you are developing a toaster, it is innovation. Now, there was a question which was asked that what are the different factors in identifying an industry for research collaboration. So I'll be very brief, and I will be saying that this is perhaps the last question that we will be answering. See, the first foremost important thing is that we should see the industry, what are their requirements and what are their areas in which they are doing work. That is the first aspect. The second aspect is we should know what are our key areas and what are our strengths. So once we know that these are our strengths, then we can always approach the industry and we can try to see whether we can have a collaboration with industry. Now, what is very important is that most of the time we work in the college or in our research lab and we do some experiment. when it is given to the industry, there is a discrepancy, and in about 80% of the cases, there is no reproducibility. That means what I do in the lab, I am not able to get the same results in industry. So what I would say is that to begin with, only you should start work or collaboration with the industry. So with this, I will end my talk, and at the end, I am really very grateful to the organization that they have given me this chance, and thank you so much.
Thank you, sir. Thanks, sir, for accepting our invitation. Now I request Dr. Rama Madam to propose code of thanks.
Thank you very much, Dr. Ashok Rao, for an excellent talk.
My pleasure.
Sir, now it's time to just sum up the day's proceedings. So, the most important are the participants, because we are all here. And out of that, on an average, I think about 800 people attended the sessions. So that's about 20 to 25% people who came for the program. That I think in today's rate is good. And looking at some of the analytics, we can see that the average time somebody is watching is about 30 minutes, which means people who are coming in are not leaving immediately. They are sitting and they are staying up to watch at least one presentation. That also, I think, is good information for us. Thanks to all the participants for all the positive comments and the questions that you have given. To summarize the speakers, we had 7 speakers today. Dr. S.P. Tyagarajan spoke about how to create an ecosystem for a good research environment. So there were some very good take-home points from his lecture, forming policies and having a common resource center, etc. He was followed by Mr. Dr. Shekhar from US. It was a very good example of how they used collaborative research across 3 or 4 institutes to very quickly give some data which has good implications for finding out who are likely to be symptomatic and more prone to COVID attacks. So that was a good example. Next was Dr. Shakti Pandi, who actually did an excellent job taking us through all the nitty-gritties of creating a research project plan. So extremely well, sir. You put out all the mistakes that normally people do and told us how to correct it. Dr. Venus gave a talk on how to be the best researcher that you can be. The most important point from her talk to me is that once you identify a research question, make sure that you have at least 3 or 4 different plans to answer that question. And using a lot of resources around us, we can effectively answer these questions. So that was very well presented. The next was my talk, and I hope that the take-home lesson from my talk would be one, I think the research question that you are asking and your methodology is most important. And just like Dr. Venil also said, if you're doing good research, collaborations and other things, and funding is sure to follow. Dr. Manoj Kumar gave us a good bird's eye view of all the InflibNet resources. I think the Shodh Ganga digital
In YouTube, is it okay? Ganesh?
Ganesh is muted.
Okay, please go ahead, madam. Please go ahead.
Okay. Oh, okay, so I think the comment section, a lot of this vote of thanks I've done has been muted. Okay, a huge thanks to the entire team. Mr. Ganesh Babu did a fantastic job helping us with the streaming the program. And a lot of thanks to Mrs. Vidya, who was the voiceover for some of the intro videos, Pritika and Bhuvana, who also did the same thing, Dr. Harshini for her very good, excellent editing, and Dr. Arun Kumar and Rizwan, who helped with screening the questions and other technical help. Yeah, is my audio available on YouTube? Just wondering. Yeah, Rizwan, can you confirm if my audio is seen? Yeah, it is okay now?
Yes.
Okay.
Madam, please go ahead, madam. It's okay now.
Yeah, so since just in case, since the audio was not there, I'll very quickly brief this. So we had about 800 participants and an average watch time of 30 minutes, which is extremely good. And the 7 speakers who were here, I thought they did a fantastic job telling us about the options available for the funding and how to go about doing that. And also, I think some of the talks are also about how to do your research. Even if you don't have a lot of funding, is there other ways to use free resources around us? Yeah, and huge thanks to the team which helped us, and of course the management of Dr.M.G.R. University, which gave us the academic freedom to go ahead with this program. And yeah, so that is all I have. And Dr. Manivannan, would you like to share a few words?
Yes, madam. It's again a beautiful journey along with the Dr. Abdul Kalam Research Center for the Faculty of Humanities and
certificate. In the comment section of this YouTube, in the explanation, there is a link given for a assessment form. Please go ahead and fill in the data there and give your comments. And then there is a link for the certificates after Monday. So this assessment you need to complete it by tonight by 10 p.m. Please complete that, and by Monday these certificates will be available in the Google Drive. Yeah, so you need to look at the comment section in the YouTube link. The
description section, madam.
Find the link for the assessment form and the link for the certificate. Once you complete the link, the certificates will be available in the Google Drive link after 2 days. That is, by Monday, you will be able to get your certificate. It will be saved as on your name. And if there are 2 people with the same name, we will differentiate it by the institute. Yeah, thank you very much, and we look forward to your feedback. Thank you.
Thank you, everyone. Ganesh, you can stop the live. Ganesh, you can stop the live.